The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man.
What's going on, everybody? My name is Nathan, otherwise known as Old Man Builds. Man, we got a fun show today. We're going to be talking a little bit about gravity. But let's just check in, see how everybody's doing, man. Paul, that's my neighbor, man. Right on, brother. All right, this is here, man. Cool. Yeah, Darren, man. Gonna get a good show in, man. What's up, Mike? Oh, man. I was dying last Friday, man, after that wing eating thing, and I went on with Mike's show, man. I was hurting. That that thing got me. What's going on, Dead Fish, man? We sent you that call. Hopefully you got the message and everything on the email. So looking forward to you getting that, man. Love your Transformer video. Yeah. You know, I think it was time that everybody learned that. What's going on, Lulu? What's up, Paul? Oh, John. Yeah, Yanni, man. Dude, we gotta rock this thing out, man. Yeah, all right. So let's just look at it, man. What is gravity itself? Well, number one, it's not a fundamental field. I think people misunderstand that. So they quantify gravity as a fundamental field, but it's not. It's actually an effect. We have causes and effects, and it's just one of the effects that comes out of something. And let me just say it this way, man. When you start dealing with all this stuff in electricity and resonance and things like this, you understand the true causes of everything. So here's the way it works. What's going on, BT? We're looking at this in a simple way. We know that there's energy in Earth. We know that it matches closely as it possibly can to a DC energy, but we know it's not DC. So it's just a little bit different. And let me just say this. We all remember the watches you used to get back in the old days. What did they run on? Well, they ran on crystal. And why? Because you tap it, it taps back. You tap it, it taps back. What is that a perfect thing for? Well, it's a perfect on and off switch, isn't it? As soon as you tap it, it turns off. Tap it, turn back on. Back and forth, back and forth, back and forth. It makes a perfect oscillator. Now you can start to understand. When you start tapping it, it has a little bit of energy in it. Continue to tap it, just like resonance works, continues to build energy in it. It is just like Tesla's earthquake machine. He tapped it, tapped it, tapped it. Very low energy, but the frequency was there. Why? Because the energy's in the frequency over time. When you start dealing with crystal, it's the same way. You start tapping and tapping and tapping. We know that's the effect that's going on the Earth. That's what's causing the energy to spread everywhere. Now, do you have other processes going on? Yes, you do. You're going to have magnetism. You're going to have heat. You're going to have iron that builds up, and you know that it's going to create magnetism. Those aren't a problem, but the fundamental starting point is the resonance point, and you have to have it. So what do we know that the three fields are that are going on in every electrical system that's going on in DC? We know there's frequency. We know that there's, we know that there's a field that goes in between magnetic, static, and radiant. So why do I always say radiant? Well, let's just look at a magnet. When I ask you to spin a magnet, You go, well, what happens? You're going to get a field. How that field builds out is important. You're going to put wire next to it and create a voltage and an amperage in it. But what you didn't realize is that you're putting out a radiant field. It's just radiant to the area. It builds out to put out the field, right? We all see it. As soon as you go to capture a spinning magnet, you start to see it. That field builds out. What does that mean? It means that you have a radiant component in there, a field that builds out like that, everywhere at once, continuous energy in different levels. That's not hard to understand. We do it in static as well. As soon as you spin something in static on a disk, you get the same thing. Energy at a distance that builds out, but it also is everywhere around it. It is still radiant. Therefore, we know those are our three fundamental fields along with frequency itself. Every time we're in a DC energy, you must have frequency. It is what controls the circuit. It is what makes your voltage go up, your amperage go down. It all is a continuous cycle. Now, what do we notice in our atmosphere? Well, when you get up towards the magnetosphere, when you get up to the ionosphere, it's static. We know that it's static. You get up there, you find it out, you run a corona motor, it is basically potential, which is static energy. You get down to the earth, you make an earth battery. What do you mostly get? It's an amperage field. We know that there's magnetic properties in it everywhere we go because it's the mineral content. As soon as we hit the mineral content, we know that we're going into like a magnetic field. What does that leave? It leaves the radiant portion. When the sun is out, you go outside and the energy is everywhere. It's everywhere. You can't get around it. It's everywhere. It goes through the walls, it goes into your room, everything else. It may not present as light everywhere, but the energy is everywhere. Therefore, it's radiant to everything around you. We know that this is true. So we should just call it like it is. We also see that at ground level, you get more heat. But as you get up in the mountains, it gets colder. We know that as you get up higher and higher, you get into the static area. As you get lower and lower, you get into the magnetic area. These things aren't exactly right in front of your face because you don't see them every day. You don't stand on the ground and feel magnetism, but the field is still there. It is three variables going on at once. You're in the radiant field when you go outside. That's the field that you're in. That's what you feel the most because that one's amplified at that point. The other two are not, but they're still present. Everything has frequency. It may build out in scalar, but scalar still has frequency in it. Those fundamental facts have not changed. So we look at it, it's most like a DC system, but it operates just like crystal. It has a resonance frequency to the planet. We see it show up when we start looking at earthquakes. Look at the earthquake machine. It is definitely a resonance ring. Goes up, builds up, comes back down. I live in California. We deal with this all the time. Definitely a resonance ring to it. You know that it happens. As you get in parts of the equator, you're going to start to see lightning and stuff happen. You get up to the 30 degree area, all of it right there on both bands, top and bottom, right at the equator, you got heat. We know that the systems are in this whole earth. We know that every one of them is working. So what is gravity then? A gravity is a manipulation of the system of those four variables. That's it. Gravity is not a fundamental system, it's an effect. It is what happens when you have these four things in your system. You can create this. Anti-gravity is more of a misnomer than anything. It's not really what you think it is because you're not going against gravity. You see, that's a misunderstanding. You're using frequencies to break a radiant field down into a field that you can connect in with different layers. You want that RF out of it. In order to do that, you have to flip the field from radiant more to an RF static field. That's what you have to do. Now, it's not that easy. It's not supposed to be that easy. You're not supposed to be flying out of Earth. So you have to take the fundamental understanding. You have to create a field around whatever you're doing in order to get it to break. You have to break from the field that you're in to get the field that you want. Now, every single UFO that you heard talked about works in this fundamental way. And it's just simply this: you are right here, you want to be here. You know the frequency here, you know the frequency here. You are simply changing your frequency to the frequency up here to move. Boom, instantaneously. That's what you're doing. If you can understand it in a DC field, this isn't that hard to get your head around. All you have to do is manipulate this and change that frequency to get there. But it doesn't work if you're calculating the field of the entire Earth. You see, that's where people go wrong with this. It never will work that way. You have to create a field bubble. And in order to create that field bubble, you have to understand the fundamentals of what you're working with. You see, if you understand it as there's a magnetic field, a static field, and a radiant field, and you know that you're in the radiant field, you simply need to flip the field. Now I need to create the field that works for me to hold this thing in. I need to create the opposite of the radiant field that I'm in. I'm in a hot radiant field. I need to create a cold radiant field, which would be the opposite. Now I can create the field bubble. What happens? The static is now being held in by it. You say, well, that's pretty odd because the Earth itself holds in the static on that layer on the outside. Well, that's precisely it. What does it also do? Well, it creates one other layer. It's the plasma layer, the layer that holds everything in. And that's the exact thing that this does. You create the radiant field. You build the static field on the inside. It creates a plasma layer in between them because they're pushing at each other. They already understand what the fundamental core of what you're doing is, so it does it for you. By bringing the resonance into the picture, what are you doing? You're vibrating this area here. You're changing at a speed that you barely can see. Now, what it does is it flips in that locality only, that field from being radiant now into a field that has all the little lines in it that you need. All the frequency lines, every one you see on a breakout of a Tesla coil is right there. That frequency, that RF is right there. Now we just manipulate the actual frequency itself to get you to move. You see, if you can understand that, and you can understand how that works on a basic fundamental level, there are a lot of things that go into this. There's still spin. There's a lot of physics that go in behind it. I can tell you that. But those are just the fundamental forces it takes to do this. So we know that if we can control the anti-gravity portion of it, the gravity portion is easy. It is not a fundamental field. It is an effect. It's why they can't quantify it. Why? It continues to change. Every moment, that plasma layer, it's not static. It doesn't just stay there. It's fluctuating. What is one of the bigger problems that goes into this? It's time dilation. As soon as you create this bubble, you're creating a time dilation field. It's working as you stand on the earth today. You don't feel the motion of the earth, yet it rotates thousands and thousands of miles per hour. You don't feel it. You're in a time dilation field. That is why it feels slower to you. That's why water isn't splashing all over the place in your little garden planter or anything like that. You don't feel it because you're in a time dilation field. That's what happens when you create static and you create a radiant field and you create plasma in between. It creates a field bubble on the inside. That's the exact process that's going on. You're in a time dilation field. You don't feel the motion of the earth, but it spins like crazy. Now, think about that. If you are sitting there and you want to go inside of gravity and now move from here to here, and you know that you just created a time dilation bubble, what happens? To every observer, it feels like you moved in a jump drive, like you hit a button and you were here and now you're here. But that's not the case at all. For you, you're moving at one speed, and for them, they're moving at another. This is classic Einstein special relativity. That's exactly how it works. That time dilation field is going on. How do you know that you created it? Spin a disk, okay? Put two of them on there, spin them, put a bunch of static electricity on them. Make sure it sparks. Now, that light and that spark is very vital to what's going on here. Make sure it goes on. It has to ionize the air around it. Now, create a field around that that has to do with the radiant energy. Use the Tesla coil, use the center of it, create the radiant energy. As you do this, now you could create that field. You'll know because it holds the static in. Just turn off the Tesla coil and let the static roam. And get ready for everything to shut off in your garage. Your computer, your TV, everything. Get ready for it to shut down because you're creating a static energy. That plays all kinds of havoc on everything. Turn on the Tesla coil field again. What happens? All that goes away. All of it. It now concentrates it in a bubble. As you have this spark over that happens and it ionizes, this is classic Hutchinson. Okay, you have to create the bubble in the field, create the ionization so that the actual air can break up. You're now pulling them out individually and they'll reattach each other on the outside. This is why you start seeing aqua as the color. Some people say it's blue, some people say it's green. Most likely it's going to be aqua. That's what you're going to see on the outside of this because it's reassembling the colors. There's reassembling water itself, the air, all of it's going in between each field, assembling, reassembling on the outside of this field. That's why the radiant energy works with water so well. In doing all these tests, we push this field through water easily. I did a test just today and put it on the members channel. And it's one I've done before on live. You just take the orange and you put it in there and you want to show if it's radiant or not. I put tinfoil right over the orange. We know the orange puts out a field. I can put it 3 feet away, no problem. We can get a field out at very low voltage because it's working mostly with the radiant energy. So what happened? You put the tinfoil over it, you're trying to create a Faraday cage or anything like that, it's completely useless. It is useless to a radiant field. Completely. It goes right through it. You put solid metal all around it. Put it in a metal box. It's going to go right through it. You got to stop it with lead. You got to stop it with mineral oil. That's how you know you have the radiant field. It only works in one way. It doesn't be confused with a RF field, which you can trap. This isn't an AC Tesla coil. It's a DC Tesla coil. Okay? An AC Tesla coil you can take and put all kinds of sparks into this Faraday cage, and it'll stop it dead. Every time, you can use chainmail and stop it. It goes to the chainmail. But you cannot do it in DC with the radiant field. It just doesn't work that way. It blows right through the metal. Every time. You put a trash can over it, everything you could do to stop a radio and RF, it blows right through it. Right through it. So, now that we understand the forces that are going on here, we know that we have radiant, we know that we have static, we know that we have magnetic, and we know we have a frequency. We understand the fundamentals of what's going on. So gravity itself is an effect. It cannot be the cause of it because it's only built when the other things are present. And if those things aren't present, you don't have gravity. If you don't have time dilation, you do not have gravity. It just isn't there. Now, can you get gravitation from an object that has it and you move in close proximity to it? Yes. Can you create your own gravity without it? No. So you know that those fundamental forces are working. We always look at Mars and say, well, it doesn't have an atmosphere. Are you sure? Because it might just be that that field isn't pushed out far enough. It may need a little more rotation in it. It may simply just need a moon the size that makes the tidal forces work on that planet. That could be as simple as it is. You don't have to go over there with nukes and blow up mountains and try to get the ice caps to go by radiating and everything. I mean, let's use some common sense here. If you understand the fundamentals of what's going on, it becomes a very simple, easy math problem. How big does the moon have to be, and how much do we have to rotate it around it in order to change it, and how fast will it start to spin once we do put that out there? I mean, think about it. You got a guy throwing a hammer and you spin him, right? You start seeing him swing and it wobbles a little bit and swing and swing and swing. Well, that's the same thing. The end of the hammer is just the moon, and we're the person in the center is the earth. It works in the same fundamental principle. So it'll affect the actual gravity on the planet, but it'll also affect the magnetosphere itself along with how it builds out. That's how it works, man. You got a bunch of energy going on there, and you just want to understand what's going on. We know the fundamental field. Gravity is an absolute effect. It just is. That's why things move around. That's why anti-gravity is simply a bubble that works on buoyancy because it's sitting in this field. And now, once you decouple the field, now you need to move it by putting in the frequency. You see, it's not going to move otherwise. There's two separate processes in anti-gravity. One is detaching yourself from gravity itself with a bubble. That's number one in the process. You don't do that, you failed. You absolutely 100%, no questions about it, failed. The next thing is you need to move the energy. Okay, Byfield Brown effect. That's what you're going to do to move the energy. It's not a hard thing to understand. All you got to know is Otis T. Carr is exactly the way he set up his OTCX1. On the outside, there's a simple C shape, and it has wire wrapped around it. That's directionality right there. As you turn each one on, that part of the ship has the frequency in it, and it moves. It moves which way you go. That's fairly simple. That's all you have to do to get directionality out of this. What's a better way to do it than spin and disk? All you have to do is create a coil that works in the same way. Take the fundamentals of the things that you use to create this: magnetic, static, radiant. You also need a frequency and resonance. You put those into a coil, you can get anti gravity out of it. You have to understand why they're in there, though. If you put them in willy nilly, you fail. We talked about the Meg today when I put out a video. That whole thing is based on frequency. If you could take the frequency of the winding that you put it in, match the core itself with that same frequency, now you're in resonance. That means that the energy that you're pushing through this thing goes very fast. If you don't do that, it moves very sluggishly slow. It ruins your frequency in there. It'll bring it down and try to bring it into amperage and try to saturate that core. That's not what you're looking for. The Meg actually works on the magnetics, giving you that amperage field for free. You get that whole field for free. You just need to know how to trigger it. That's the point here. In that device, you simply add frequency. It triggers that core itself. It goes to one side. If you're dealing with one that has a top and a bottom and two sides, one side will get strong, the other side gets weak on the magnetism. You then hit the other coil. What happens? This side gets strong, this side gets weak. That's how it works. All you're doing is shifting it one to the next, one to the next. When you go over and look at the temperature on it, the temperature fluctuates. This side gets hot, this side gets cold. This side gets hot, this side gets cold. As you flip the field on that, that's the way it's working. The current itself is cold. Magnets are cold. It is current trapped in a body. of a magnet. That's it. That's why it works that way. It's cold. So what happened? You have the magnetic field and the dielectric field builds out from that. But what's going on inside that thing is the magnetic field is on the inside and cold. So the dielectric field tries to follow it. It's a game of chase. It simply pulls into it. So what does that mean? In every dielectric field, the reason it has little spaces in between each one is because it's layer of air and plasma. And because of that, it draws in the plasma into where you're going. It's drawing it in. It's taking that air and using it as a guide and it's drawing it in. That's as simple as it gets. It goes into the center because it's trying to get to the magnetic field inside. It brings all the plasma in with it. That gives it more energy. It amplifies in the amount of energy going out. You simply have to balance the capacitance going out. Usually you put a light bulb on something like this and it draws it in. Any cold energy circuit, as soon as you put a neon light to it or a fluorescent light to it, what does it do? It acts as a draw. That means that it takes that energy and says, come here, come here. I need you. Come here. I got enough capacitance in this light to hold you. Come over this way. It goes into there. It breaks the frequency. Then you put it into the capacitor. Now you have something that's broken. What do I mean by breaking the frequency? It no longer bounces back into your system. It stops the back EMF at that point, pulls it out. Otherwise, you get a spike in your system because it hits resistance. That resistance will cause a spike. Why wouldn't it if you put a neon light in there? Because you're burning the energy a little bit. It's still transferring through, but it's radiating a little bit of heat, so it burns a little bit of the energy. Therefore, it stops the frequency in its tracks from changing. It bounces out in the capacitor bank. Then you can put it back into a battery or whatever. It's a leveler. It changes it back down to 12 volts, or you can run your system again. Or you can use the capacitance if you put a duty cycle on it to run anything you want. That's the Meg. We understand all the fundamental forces are still there. We understood the frequencies there, the magnetic field. We saw the static field or the dielectric, if you call it that. All of them. The radiant field is also there because it's not pushing out, it's pushing in. You see, you change the understanding of it by changing how the current works. All you do is make the current cold, so you pulled it in now. Now it pulls into the system. Now you have an understanding of how the Meg works. But it's every cold energy system. You want to create a room temperature superconductor, right? Well, how are you going to do it? Well, you got to pull in that dielectric. You have to make the room work for you. If you understand conservation of energy, it can't be created or destroyed. What does that mean? It means that it's everywhere. You can't say, well, I created this, generator over here and I'm making energy. Why? Because you can't create it or destroy it. Therefore, all you're doing is creating an apparatus to pull in the energy around you. You're simply making it so that the energy comes into it. That's exactly what that quote means. Now that you know that you have a field that's radiant everywhere, it makes more sense. Now that you know that, you can now pull the energy from the room itself. You can pull the energy from the environment itself. All you have to do is create a better trap for it. You see, you can use many devices. They're all going to work the same way. You can use a rodent coil to do this. I do it all the time. I can make that sucker colder. Why? Because it's all about rotation of energy and where you put your magnetic and if it's cold or not. Then it gets cooler. What starts to happen over time? It'll ice over. You'll get a device that ices over. And it'll freak you out. Because as soon as you start seeing the rodent coil ice, as soon as you start seeing a Meg ice, what is it telling you? That you pulled in a ton of energy from everywhere, not just a little bit. There was a lot more in there than what you thought there was. It's the fundamental understanding of how this kind of energy works. You see it as you build it. If you can build cold energy and you see it pulling towards the heat in the light bulb, you see, that's why cutting an orange and a half works. So let's look at this. And I did this test. 2 slices of orange in there, you got a radiant field. Now, I don't care that it's an orange. It's basically liquid in half a sphere. Okay, you can call it that. That's what I care about. You put it together, and it'll take that water that's 360 degrees. Now make the energy 360 degrees. Now you start to understand things a little better. The outside of it now is like the crust. Like, so if you want to put this in the earth and do it with water and mud and the ground, you could do it the same way. You get the energy into the water table, you put the dirt, now you put the light bulb on top. What happens? The light bulb lights up brighter. You do it with the orange, you get the same effect. But now that when you cut that orange in half, what happens? This side over here is activated because it's actively going to an energy system. This side has no activation. It is sitting there just plugged into a light bulb. Why does the light bulb turn on? You see, this is what people just like to skip over. There is no RF in the world that does this. The radiant field itself is pushing over in the dielectric between the two halves of orange in a one that's turned on, one that's turned off, based on the water putting out the radiant field. Can't do that with RF. Get it in there, turn it on. This one turns on. The light bulb is pulling the energy into it. It wasn't forced in, it's pulling it in. It acts as a capacitor in the system. It's pulling that energy in. That's why these tests are so important, so you can see stuff like that. You see, not everything's what you think it is. You could read as many patents as you want. You won't see this. You won't see this information everywhere because people don't understand it. They keep calling it the wrong thing, misclassify things. They broke it down the wrong way. Every time. Every time. Why on the MiG would you put the two outside cores in a quarter wave or a third wave? Why? Because they get more energy that way. You're getting the amperage from the core itself. You're just looking to pull in more to it. And as soon as you pull in energy that goes in to there based on resonance, the plasma amount goes up because of the core itself, because of the iron, because of the space you put it in. You light up a light bulb all day long. You don't have an issue whatsoever. You turn them on. They go so fast in switching. By the way, that's another reason itself why you want to use crystal in this thing. You want to use crystal oscillation between the two. A transistor and MOSFET's okay, but crystal oscillation is better. It is the most consistent frequency and oscillation you'll ever find. That's why you want to use it in that type of system. The on-off switching is so much faster. It's so much better. If you could just understand that's about crystal. You tap it, it taps back. You tap it, it taps back. It is the perfect transistor. Here's the thing though. You can blast it with heat all day long. Transistor, you can't. You can hit it with cold all day long. You can't do that with a transistor. That's why oscillation with crystal works so much better. Crystal oscillation in that system is perfect. It is better in every system we look at. I would like to build my Tesla coils with that same oscillation because now it's completely consistent. The faster I tap it, the faster it taps back. It is perfect for resonance. That's why it bounces back and forth in the earth that way, because it's resonating one to the next, one to the next, one to the next. You get all your fields in the earth. I'm not just, trying to destroy anybody's thought of this. You're still creating an iron core. You're still going to get it to heat up. You're still going to get magma in there, but you need those for amperage, don't you? That's not a problem. We understand that the field that we're standing on has more amperage in it. We understand the atmosphere itself has more static. We understand the field in between to be radiant. Creating it in the lab and seeing it. You don't have to use Tesla coil. You can use any coil you want, as long as you understand the fundamentals of it. I say Meg, I say Rodin coil, we go geometry coil, we go Tesla coil, but you can create them in all of them. As long as you understand the fundamental principles in which you're working, now you can create them all. You see, you go, well, man, are you really creating a radiant field in that Tesla coil? Okay. We'll just go get out and we'll go get an X-ray bulb. And as soon as I put the field in there, guess what happens? It puts out X-rays. And you go, well, that's radiation. You know that, right? It put out X-rays, radiation. Well, yeah, I know that. Yeah. That's why they tell you when you look at spark gaps and stuff, it's probably putting out a small amount of radiation. And you go, wow, it's probably too small. Well, maybe not. But when you compress it, it becomes too much. So that's all that bulb's doing is it's compressing that energy and giving it a direction. And as soon as it gave it the direction, it put out radiation in one direction. Now you can understand the principal understanding of this. You're getting the energy right. It's got to be high voltage and it's got to go in there. As the more you compress it, the more energy you get in radiation. Therefore, you must have started out with something that has a radiant component to it. So you see, everything does. You go to a magnet, it has a radiant component. There's a distance it travels that goes out from it. In static, you have a radiant component. Every time that you build it, there's a distance goes out and it travels. That's what radiant means. It's radiant to what you're doing. It's pushing out a field. I read some Tesla stuff, and he was saying that when he created the first Tesla coil, he was talking about static electricity. And then he would say radiant, and it's flat out in his patent. He says it back and forth. Static, then radiant. And he keeps going back and forth between the two. It is simply because as soon as he created it, it went through everything. You see, he knew that it was probably supposed to be static because of the amperage and voltage in a DC system. What he didn't expect is he found the radiant field. You see, he knew it was there. He knew it went through everything, so he could not call it static. That's the problem with the whole energy system when people say it. It's RF. It's static. Yeah, well, did you create it and check it? That's the first question I have for you. Did you create it and check it? Because that's what you're going to have to do to verify it. You can't just read notes and read everything. You got to verify it and check it. There are secrets in this stuff to do this. And once you see it flip, once you can see each field flip to the next, you know exactly which one you're in. You can tell exactly which field you're in and how to manipulate them then. How do I go from this field to the next one? Well, if I have a radiant field, what do I need to do? I need some form of compression, which is basically putting a core in it. Now I can bring it down and get me closer to a magnetic field. You see, that's a very simple conversion. Now I can take a magnetic field and build it out into a static field from there. You have to go in the order that it goes in. You don't just get to go from radiant to static. It doesn't work that way. You go from radiant to magnetic, then you can create static. All of them are in there as fundamental fields, but you have to know that when you convert. Now that you know that, you can play with every little part. What's the one thing that you don't realize you're playing with? And that's the temperature of everything. It's because of the frequency that you get temperature. And let's just look at it in a DC system. It'll be very easy here. Okay, very fundamental on how this works. If I bring up the frequency, I bring down the temperature. If I bring down the frequency, I bring up the temperature. So when I brought the frequency up, I added more volts. When I brought the frequency down, I added more amps. That means as soon as I add more amps in any system, I add heat. They're all related. Now you can understand the fluctuation and flow of what you're doing. If you have a static field and you want amperage, you need to slow it down. That's why you put it in a duty cycle. It slows it down and stops it, lets it build up. As you build it up, it builds heat. As soon as you put something into a full bridge rectifier that has a lot of voltage, you can put your camera on it and you can put a temperature thing on there. And what you're going to find is it starts heating up. Why? Because you're backing up the voltage in it, and you're bringing up the amperage. As soon as you put that in there, it immediately does it. You immediately see it. As soon as it does it, now you know that you're converting. You're taking the static or potential, you're putting it into magnetism, and you're creating amperage. Now that you have the amperage, now you can use it in your system for what you want. That's pretty simple. It's an easy conversion. You could take the radiant field and run as many Tesla coils as you probably want. That field does not stop. It does not slow down, and it's continuously going. It's everywhere. How else do we know it's there? We take a vacuum chamber. As soon as you take a vacuum chamber, just understand this. You're putting the negative on the outside of the chamber. You're putting the positive dead center in the chamber. Now you're putting the energy into it that's high voltage. It pulls out to the negative. Again, pulls out to the negative. And it creates a radiant field in the inside. It all goes one color. Just understand the process you just did. You pulled out the energy from the center part because you're in a compressed field environment. Your earth works the same way. Now, on the outside, you have your negative. On the inside, you have your positive. Guys, it's not that hard to figure out. What's the difference? We're not looking to suck all the air out. As a matter of fact, we want a positive pressure environment. The exact opposite. Light's an effect, guys. I don't know that everybody understands that yet, but light is absolutely an effect. It's not a cause. It's an effect. How do you know that? Well, I could take high voltage and go through the rainbow. I could just change the frequency of every single one of them and get through the entire rainbow. Not a problem. I can create light all day long. You want to create a laser? Use some high voltage. You can create a laser out of your high voltage. Use aluminum. Works really well. They use DC flybacks and put them on a metal table and create two little bars. Goes right down from it, and then they can create it. What's the third component you sometimes need to it? Gas. That's not hard. We have gas in our atmosphere everywhere. Not very difficult to understand it. You can create lasers out of it. Light is an effect, not a cause. That's why it's dark through the whole solar system. And as soon as you get over towards any planet, you get light. That's the way it works. It lights up. Looks dark everywhere else. Plenty of light by a planet. Plenty of light by the sun. Plenty of light everywhere that you see one of these things. That's why. Because light is an effect. It's based on the energy of the planet itself. So when you get it into the earth, we know that everything's dark and everything in your room is a reflection of whatever color it is. We have a fundamental misunderstanding about light. Particle, non-particle, I could care less. It's a simple effect of energy. You can call it anything you want to quantify it. I don't care. I can create it by just simply creating an effect of energy. That's it. It makes it as simple as you can get to. Do I see electrons? No. I honestly I don't. I see fields. How do you quantify as that's not my cup of tea, guys. You can quantify them any way you want. I can see that they build up in a system. I could see that they add resistance to a system as soon as you have them in there. It's an impedance. That's why you have some kind of a magnetic field. It's just an impedance. It's the same reason why you have, these little lightning balls or whatever you want to call them, EVOs. What is it? You created some kind of radiant field and you trap static inside of it, and now you have it. And if you put it in your system, it creates havoc. Why? Because it makes resistance. It's saying that, hey, I cannot travel my energy through this because you're screwing up the oscillation in this energy. And now I need to produce something to have the energy in it. And then it's going to slow down your energy, by the way. That's what it's going to do. So that's how they're created. They make simple little plasmoids on them and slow you down. That's your electron. Okay. They don't come out all the time unless you're in positive energy. It comes out in positive, but it's built through negative. It's not that hard. The outside of it's going to be heated, but the inside's going to be cold. And because of the two, you have a temperature differential. A lot of this stuff just works on those same fundamental fields. Gravity's the same thing, it's an effect. Light's an effect, gravity's an effect. If you take light that's in effect, can you create matter out of it? A lot of people ask that. Well, what do you have to put it through? Well, you have to put it through an energy field. You ain't doing it without it. I'm sorry, it don't work without it. You need to create the energy and mass. Just like it's building Evo, it's got to build mass the same way. It has to have the energy fundamentals inside of it. Why? Because what you're doing is you're breaking things apart to a fundamental level. You're just basically tearing the light up. The light is more than light than what you think it is. There's energy in that light. That energy is traveled through the four fundamental things that we've just been talking about, has to be in that light. That light goes in and you have to create a field in order to break it apart. It has to be ionized in there. As soon as you do that, you can start to tear things apart and rebuild them the way that you want. Now, when you put them through there, the frequencies that you put them through dictate the outcome of what you're getting out of it. Now, there's ways in this to do this to create things that you shouldn't be creating. And I don't like to talk about it on this channel because I don't like the government in my business. But as soon as you start creating them, the government comes after you and takes it away. You cannot create currency. Not something you should ever do. It is bad. The government does not appreciate it whatsoever. It's a fundamental part of science, though. So we do know that it exists, but it's not just light. Please understand that. You have to create the energy fields and the frequency in order to do it. Walter Russell had it right. He knew how to do it. But he also knew, man, that you have to do this thing and not do things you shouldn't. Okay? That's why I don't get involved in it. I don't even try to do the experiment because I know. Do we do the coils and stuff like that? Absolutely. We find all the fields in it. And when we get to that point, those cameras goes off. Nobody talks about it and we walk away. That's it. Is it possible? Yeah. But some things in system memory and dealing resonance, you have to change the system itself as you go. As soon as you create mass in a resonant field, you've changed the resonance itself. Therefore, you're now out of the field that you thought you were in. Completely out of it. You're going to create something different. So why does it stop? Well, change the frequency of it. We're listening to a gentleman who goes out and does all the Tesla tech and stuff like that. And he was talking about a generator and an alternator. And you put them together and he put this wire out and it's looped. Okay. And he says it started running by itself. Okay. After you put the first battery spark in there and got it to go. Now, how does that work? Well, the resonance of the two coils have to match. That's it. The wire loops themselves, they're creating chokes. The chokes brings up the amperage. He said it would fail after 2 days of running. Why? Because you didn't understand how the energy worked. You didn't understand that every single time it cycled, the temperature changed. Once the temperature changed, the volts and amps changed. You see, if you don't understand the fundamental of how it works, you'll never understand why it failed. It simply failed because it went out of resonance. That was it. You can calculate the exact time that it ran and find out exactly how much it went out. It's that simple. You just ran it and it changed the field on you because it added a little more amperage than you thought or a little more voltage than you thought. And that resonance frequency changed. Tesla coils are the best way to see it. And I'm just going to tell you this. They do it quickly. It's like high voltage. Everything you blast and stuff that's high voltage or Tesla coil field, it immediately shows you what it's doing. It doesn't hide it. It's not a slow building process. It's a very fast process, and it shows you things really quick. Now, in some of the other systems, they do it very slow. So you have to understand what it's trying to tell you. When it tells you it fast, you have to put that in your head and say, okay, but in a slower system, it's going to take more time. So now I understand, okay, it may take a longer time to get there to show me the same thing the Tesla coil showed me, but it's still going to show me the same thing. Now I know I have to manipulate it just slightly to retune it. As soon as you retune it, it continues to go. That system can probably run forever if you accurately tune it. Now, let me just tell you this. You could spend multi-thousands of dollars on hardware, okay, all kinds of meters in the world. It will not help you if you do not understand that. If you cannot understand the DC field and why it works the way it does, not all the meters in the world are going to help you. They're just paperweights at that point if you don't know how to calculate what's going on. And you don't have to use a bunch of math. You can, it'll help. But yeah, it's a feel. You should know things by the time you're done with how it works because you understand the process. That's why a lot of the old school tuners, man, they don't even use this stuff. They just go over and go, okay, you need this, so they'll drop a capacitor right in there and have it working, no problem. Because they know. They already know. Anyway, gravity, like I said, it's an effect. Quantify it any way you want. Don't really care. Not my problem. Not something I have to deal with in physics because I work on an engineering end. I tune systems to resonance. That's what I do. This stuff right here, man, it's all field effects and how you create it in a DC system. You just have to realize that the Earth itself is not exactly DC. It's close, but it has to do with crystals. And as soon as you can figure the crystal oscillation out, which we already have, we use them in a lot of DC systems. Heck, I can go over my washing machine and find a crystal in it. That's not hard. I go to my radio, I can find one in there. There's a lot of systems that use them. Man, they make millions of dollars making crystal stuff. I think my computer's got a couple of minutes. Heck, that's a microchip that has layers of them. My graphics card's got a ton, man. The stuff's everywhere. Why? Because it calculates ones and zeros on and off all day long. That's all it is. 1 0 on off, 1 0 on off all day long. That's all it does. That's why they don't put 3s and 4s and stuff like that in there. 1 0 on off, on off. That's all it does. So they use crystal for it. So it's a perfect oscillator because the timing can be perfect. That's why. Anyway, guys, sorry I got to get into what you guys are saying in the chat. Enough of me out here talking. So, oh man, look, I don't flow with regular physics. It doesn't always agree with me. I do things based on the test and what I see. That means that a lot of assumptions that people have about their things they've written, they read, everything. I need to see the test because there's so many things that contradict each other in physics itself. It's ridiculous. You have the same conclusion, but if you didn't understand the machine you're doing, it's going to come out wrong. That's why you can have all the physics in the world and you make something for $2 million that looks like something that I could have created for $10 at a yard sale. I mean, so many things are opposite of what they should be. But if you stick with the fundamentals, man, and you go, okay, I know it's doing this. I can see it's doing this. Now I can build it out. Now I have no problem. Which field do you want to be in? I can put you in it. Where do you want to be in your resonance? I can put you in it. What do you need the value to be? What do you need it to resonate at? If I wanted to create a transformer, all I have to know is the core value. Talk about Floyd Sweet. Let me just say this. He took a magnet, and Tom Bearden likes to say it does work. But what's the work he's doing? He's oscillating it on, off, on, off, on, off. He takes the magnet, sits it on the table, puts a razor blade on it right in the center, and it goes like this. That's Floyd Sweet. Why? Because he knew that it was resonating back and forth. It was oscillating perfectly and doing it by changing the material of the core itself, of that magnet. You see, that's the important part here. Everybody doesn't understand that. It's a simple oscillation factor. That's what we're doing. Oscillating, oscillating, oscillating. Floyd Sweet did it the best. And he used materials to get there because he knew how the system worked. When everybody told him no, he still built it anyway. And he said, yes, it does. Sorry, they had to rewrite some physics in order to add that oscillation in there. You do know that, right? They had to rewrite stuff because he was right when they all told him he was wrong. Sorry. If you want to talk about bees a little bit in anti-gravity, man, if you understand resonance, it's not hard. You understand cavities. That's what that whole thing is about with the bees, man. Resonance in a cavity. As soon as you do it, it already has compression in it. It already has it in there. People think that the energy is the fundamental force, and it's not. It's the resonance. The resonance is the fundamental force. That thing right there, without that, you don't get anything. That oscillating frequency back and forth is so important. The bee's wings, you get into a beetle's wings, you get into the shell of it. It keeps moving back and forth. They're creating all the energy in there. All of the people that deal in anti-gravity know this. They already know it. You look at electrics. Well, I'm going to tell you right now, man, that was created a long time ago. And probably, I want to say this, the best ever at it was T.T. Brown. He understood the K value, he understood how to make the levels of it and build it into a capacitor. He made an electric in order to make it into capacitance in order to use it in the system. The second system he used was the Tesla coil. Go figure. The same fundamental forces we're talking about. Static, magnetic, radiant, and frequency. All of them present in his device. All of them used in a very particular way. I mean, you can go back and look at every experiment that they've done on anti-gravity. Otis T. Carr. That's the coil in the center. He got the magnetics in it. He got static in there. He got capacitance in there. You put on the outside field and he's got compression. Why do you think that they put in there aluminum, bismuth, aluminum? What's the significance of that? Because the bismuth isn't the crystalline you see. No. It has another value to it. You see, it acts as lead. As soon as you squish it in between there, it's acting as lead. It's going to have a partial bismuth property and a partial lead property. The aluminum itself puts off an eddy current that holds the things at a distance, right? It pushes it off. It doesn't like it on it. So how do you create a great capacitor? You put some bismuth in the center of the aluminums and you have a beautiful capacitor. Now you can trap properties in there you can't before because bismuth's rate of energy goes like this. Beautiful thing to watch, but it's in anti-gravity for a reason. So, yeah, not everything's what you think it is. You have to track down the parts and what they become once you melt them and change them and put them in different things. Also has a low melting value. You create too much capacitance in there, what are you getting? You're getting a liquid bismuth. Think about that. If it's not in cold energy and it goes to hot energy, you're getting liquid bismuth. has a very low melting value. The aluminum has a high melting value in comparison to the bismuth. You will literally get liquid inside of there. Therefore, it'll change the field again. So you have to look at that. What is it doing to the outside look of it? When you look at this thing, is it looking like a mirage? Are you getting a field that doesn't look right? Why? Did you liquefy the bismuth inside of it? Maybe you did. Maybe that's why it doesn't look the same. Maybe that's why it's putting out different effects. You have to understand these things. Which one couples well with each other? And why do you want that energy? A lot of these things, people that go to build these out, and engineers have to study for a long time to figure these things out. There's a lot of fields out there that are just created by different materials. Did you know that you take static electricity and then you put mesh to it? What happens? Well, in that mesh, it builds up the field inside there better. It creates a higher value. You're able to move material in static that's too heavy for static because of the mesh itself. This has gone over, man. They already know this. They have physics on it. That's why when you lift paper little lifters that look like UFOs, man, you do it in an energy field with two DC flybacks instead of static electricity, you start understanding this. That mesh itself is important. It's the way that you have to build things in order to get it to have the static value. That's why, yeah, a lot of high K value, a lot of mesh, things like that are all in TT Brown. All of it. You know, some of that stuff that they put out there, oh, it's a lifter, it's a lifter. Lifters cease to lift when you get over a certain weight. Let me just clearly state that for you so you understand that. They fail to lift over a certain weight, period. You're dealing with a secondary force. That's what a lot of people will never understand. You're playing a game of cat and mouse. You're literally creating a field here that pushes upon the other field in order to drive it back up. That's the fundamental force you're playing with when you get into something that TT Brown's working with. The stuff that you connect to your old CRT TV is based on ion wind. Two totally different forces, built almost the same way, completely different reactive value. Just the way it works. If you don't know, you don't know. I mean, ion lifters are great. I mean, get the weight down low enough, they have enough push to it. 2.2, oh God, I'm trying to think of the thing was something per second. S over C or something like that. Anyway, it's very slow. It's about the same speed as your fan for your computer puts out. Meters per second. Sorry, meters per second. That's about how fast ion wind is. Yeah, can you multiply it with multiple ones? If you know how, yeah. You can. Can you get that number up? Yeah, but then your weight of creating the lifter itself or thruster at that point would be too high to lift anything. Completely useless at that point. Move a little boat with it. That works. But it's not going to do much. Now, if you get into an environment where there's not a lot of weight, then it will do something. And then you'll have to learn how to amplify it a lot better. But you have to understand what you're in. Are you in ion wind? Or did your lifter change because you changed how it works? Are you chasing a frequency? See, there's two different things going on there. You talk to a static specialist and they'll tell you that. There was one that they did over at Falcon Space and they were doing the tape machine, right? And they're trying to create the static field that creates a barrier, right? So let's break down the original thing. 3M did it wasn't an experiment, it was more of a problem in their factory, right? They created a field in there that they could barely walk through. You have to back out of it. It was so thick. It wasn't interacting so much with the environment, though. So, first, you got to look at what the field was. What did you think it was? They thought it was static, probably holding back some static, but then static goes everywhere. It doesn't stay in the same spot. There had to be a secondary field happening there, a conversion somewhere. And the answer comes in, do you understand factories and how they work? I worked in a soda factory in the production facility. I could tell you, they try to take everything and the static out of everything. Okay, ground it out, put it in the ground, everything that they possibly can. What would fail in a system like that is a motor. You get a motor that has loose wires, you get a motor that shakes and has loose wires, stuff like that. You start to get a component. It starts to fail on the inside instead of making a heavy magnetic value. It starts to make a heavy static value. Maybe the magnet in the motor went bad. You never know. But when you find the fundamental problem, it gives you the answer to the system. You're getting static with the tape. We know that. We also know you have a conversion going on there. Therefore, your motor had to be bad. You created a field to hold in the static continuously. They didn't see that when they did their experiment. I know it's there. There's also a temperature differential going on in there. If you walk into a warehouse, they're all cement. We've all seen them built. They build the cement wall on the ground, they stand it up. All the factories are like that. They do not like wood walls. They do not like insulation. They do not like anything like that in a factory. They like cold, very cold environment. You used to have to wear a jacket to work every day. That's what they're in. Once you understand the fundamentals of what goes on in electricity in that field, and they're creating DC fields, they're not AC motors, you understood what happened there. So when you go to recreate it, you must now create the fundamental field. Well, every one of them fails because you can't take the environment and make it hot. The environment needs to stay cold. The more cold, the better. It's like the heated house, right? House is hot on the inside, cold on the outside. It creates a barrier in between. That's pretty simple to understand. You needed to do the same. Cold on the outside, the inside needed to be a little bit warmer on that barrier, and the inside is cold because it's static. That was the answer to that whole problem. But what did the technician do? He came in and changed the motor out and called it a day. There you go. Problem solved. That's what most technicians do. They come in and they go, oh, it wasn't grounded properly. It was doing this. The motor went bad, pulled it out, replaced it, and there's their day. Okay. All day long, you see it in the factory. Not really a problem. Once you understand what they pulled and did, you understood the whole problem because you understood which field you're in. Pretty interesting concept, though, in itself. So, yeah. Oh, bismuth. Yeah, bismuth ferrite gets a charge in the. Let's see. That's why bismuth ferrite gets a charge in the presence of a magnetic non-motion needed. The field already moved. Nikola Tesla documented that. There you go. Michael's got it. DC is being phased out. Well, yeah, of course they want to get you away from everything that is going to work for us. Or one-way direction. Yeah, they like that three-phase AC. I'm not a fan of it. Not a fan of AC. Even in Tesla coils, it changes the understanding of why you build one. You're trying to build fields on the Tesla coils. You put in AC, you're building a sparkler. So now there's a way to convert things like that and do things cool with it. And Sean does it all the time. So please don't misunderstand what I'm saying. I love high voltage sparks. Okay. But in a Tesla coil, it makes you misunderstand fields sometimes. Let's see. That's called ferromagnetics. Fly through glaciers. I'm not sure where that came from. Probably something I missed. Cool stuff. Yeah. Dude, this whole subject is cool, man. Yeah, they are. They really are. Now, the way Sean flips that field, though, where you can put your hand next to it and it doesn't bite you. Oh, dude, another level. Because when he puts that negative to it, it pulls in the negative. Then he gets even better, okay? Because he does field flip it, and I love Sean and his work. He took a spool of wire and put it up there as a negative, and it still pulled energy. You ask a physicist about that, and they go, "Well, that's not supposed to be possible. It's supposed to go from the ground because we know the ground has amperage, right? So it goes up in there. Not a problem. They can understand that. What does the spool do? It's just open to the environment. You, in order to say that that works and quantify that it works, you must say the energy comes from the environment. That's a fact. You can't get around that. It doesn't change. In order to say that that process works, which you can see with your own eyes, the energy has to come from the environment itself because it's not pushing to the coil, not pushing to the spool of wire. It's taking the spool of wire that's connected to nothing and pulling it in. I've heard the thing, and Sean tells me it's electrons. But there's only electrons if you have a field next to it. There has to be a field creating those electrons to go to it, and then it has to convert the field. Therefore, there must be a fundamental field that's building into the coil itself in order to push it towards the Tesla coil. Same cool thing, man. It's all there. All there. Love that, man. Pulls in from a flat out spool of wire. Love that experiment. Yeah. Oh, man. Yeah, lump of quartz, man. I got the same thing in my front yard, man. Yeah. Dude, it's a trip to see. Like that, I'm so excited, man. If you build me that round coil, man, so excited because I want to create that same experiment. Because then I want to take every kind of coil in this world and put it to it and see what kind of energy I can pull out of it. You go, okay, if it works here, where does it work here? Where does it work on this? Can I use light bulbs? Can I do something else? What can I use on that other side to pull the energy in? I need to test it all. Because then floating ground, I mean, that's essentially what it is. It's a floating ground. You know it in your electrical system, it's a floating ground. So what is it doing? Because as soon as you figure that out, now you can use it on your anti-gravity craft, right? Perfect thing. If it's pulling in the energy from the environment itself, then you would necessarily want that on your craft, wouldn't you? You'd want it on the outside. Heck, that's a whole shell of your craft. Think about that. I'm up in the environment, and now we can take Otis D. Carr's understanding of over unity in that system, in the atmosphere, and understand why he said it was over unity. Because it's pulling in the same way that Tesla coil did. It pulls the energy from the atmosphere itself. And it's bringing it in hot, man. It was white voltage in there, okay? We knew it had amps. That's what's cool about it. It's another set of proofs that's going on. Time dilation. Ralph Ring was talking about that, right? He said Otis D. Carr had of getting the craft and then, do mental stuff to get it to move, right? And he said he didn't remember anything until after the whole scenario was over. And I guess he went over and picked rocks or plants or regardless of what it was. He didn't understand the time had passed. But in his recollection of it, he knew exactly what he did. So that's time dilation for you. It put him in a time dilation field. He can move the craft, get it somewhere, and come back. And if you're not protected from time dilation, guess what? You ain't remembering it, buddy. You're getting blank mind. That's what you're getting. But yeah, it could have been shrooms. Well, there's a lot of things that could have been shrooms. But the fact that he's standing next to a story until the day he passed, man, tells you a lot. Okay. He knew what was going on. And if I was a government man, and you had all that control, you'd probably hide it too. I mean, Yeah. I don't know that I would blame him for that because that's I mean, there's a lot. We're just telling them flat out how it is, man. That's the way it works. I mean, there's a lot of things the government has they won't tell you about. And they just started doing it right after World War II because they started finding out. I mean, think about what is radar? What is radar? It's a magnetron. It's frequency over and over and over again. They create little bars, goes around in a circle. You have a core to it. It has like what looks like a little spring. Okay, different material. They put in the energy and it creates an energy like this. And all it does is hit the same frequency because it's the same distance between each plate. All the way around, all the way around. Again, 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 again. What does it do? As soon as they have that multiple frequencies doing that, it creates your microwave. Well, they're using radar. They just put a little loop in one of the things in there, have a little loop wire that comes out, and it picks up that frequency. Not difficult. It's what they did. They understand the fundamental forces of something, so they go, okay, we're going to manipulate this. They say the first UFO that went down, what was it, Roswell? What happened? Well, you see, it's that same thing, that radar, that got them. Why? Frequency that's consistent puts things out of balance. Horses on a bridge, too many people on a bridge. Hit the resonance frequency of the bridge go crazy. Goes around, falls apart, everything else. Why? Because the frequency changed it. It put them out of the field that they were in of a radiant field and put them into a different field by changing the frequency. That's a lot to take in and understand what the forces are that really did it. It's the way it works, man. So when you look at it and you go, okay, frequency consistent like that, and we put it in a radar and you took down a UFO, why? Wow. Why? Because you just basically dropped it out of the whole sky because you use frequency. So what do they do now? Well, the government has perfected that process, and now they have energy weapons that take planes out of the sky. Why? Because you're putting a consistent frequency in a directed beam at something, and it screws up how it fundamentally works in nature, and now it drops right out of the sky. It's like turbulence, but amplified. It's just too much of it, man, and you're going down. They perfected it. Heck, they use energy weapons as crowd control. Think about it. Frequencies that they can match to your body that make you sick. We're all dealing with the same fundamental forces. They're just simply amplifying one of them. I mean, think about it. That's all they're doing. It's not like they're hiding it. You can't hide that. That's why I tell you guys, when you start making things and you put a Tesla coil inside of a Tesla coil inside of a Tesla coil, hey, just number 2 coils, you're changing something. You start putting aluminum in there where it can compress, man, you got something there. You either got a thruster or you got a beam weapon. It depends on how you build it. Certain things I just won't show on the channel, but they're there. But you have to be a master of resonance to make them work. Because it completely changes from coil to coil to coil to coil. Every single one you hit, it changes frequency, and you have to be able to adapt to all of them and understand how to fix it. Anyway, all of it's manipulation of the same field, guy. That's it. Tesla knew it. We all knew that. That's why he was going back to all the inventors, man, and saying, hey, I didn't see what you saw, because he would rebuild every one of your experiments. You see, you can fluff things up and hide things a little bit, right? And then write it down. But then someone goes to verify your work, they're going to find your flaws. There's no getting around it. It's best to just be honest about it. Say it for what it really is. You know, we're not trying to get in the newspaper here, man. We're just trying to get this understanding of what's going on out there. Everything kind of curves into it. You'll find out every system you build, you go, okay, This old man says it's the same in every system that I build. As long as I have these simple factors, I put things in resonance with each other, it'll run smoother, it'll be faster, it'll put out the energy I want, right? That's what he said. Then you go to set it and tune it, and you forget all those things, and you just shove a bunch of energy in it, right? We've all done it. Oh, man, I hit the gas. That's what I want. I'm guilty of it, very guilty of it. Doesn't work that way. Just doesn't work that way. That's why you can take energy systems that you put very little energy into them, but you have the resonance correctly and correctly put in there, and they make way more power because you understood the fundamentals of energy. That resonance, man, it's a monster. Creates earthquakes, creates everything. That's why when people say they want to tap the resonance of the earth, well, I don't know that I want to tap it. I'll use it. I don't know that I want to tap it at all. I don't want to bounce it back at me. No, thank you. I'd rather do something else. I want to pull it out in the amount that I want it in. That's why a capacitor between the field that's up there and the field that's down there works perfect. Now I can decide exactly how much energy I want to pull out. I got a total value. I have two coils. I bring them back and forth to each other, just like we see with the orange in the test. Energy level changes. We're good to go. Okay. I can decide exactly how much I want to do it, and I can pull out the energy I want and not more. That's why it works that way. Tesla's death machine. Oh, yeah, he created it all right. But don't ever let anybody tell you any different. He did. They don't want to tell you that, but he did. You know, a lot of the modern things are built on some of the stuff that he did because he's a master at amplifying systems, is what he was. You say, well, you didn't create this. You didn't create this. You know, a guy named Odin created the Tesla coil that we know of now. Yeah, maybe. Tell you what, though, this guy can master it. I saw a thing on there, man, where they created Tesla coils and they hooked the frequency generator to them. Well, that's great, an antenna. I love the antenna, man. But a Tesla coil is about multiple coils in resonance with each other. No matter which ones you do, that's what they are. So, although I think the antenna with the one wire is cool, I love the experiment, and I can see why it puts out a good field from it. It's not exactly the way he built it. It's got to have the two coils factor to it, not just one. So, a little bit different of an understanding because you get resonance, which changes the energy in it. Yeah. Oh, let's see. Please try a plastic core for your Tesla coil. I think it's you electrics, just like we do electromagnetics, and they get everything and test it. Please show me what happens. So if you're just talking about like fill it in with plastic, or you talking about like a cutting board material, melt it and built it, that would be something if they sold it in a core, you know, round core, and I think they do. I would try that for sure. Um, let me say this when it comes to an electric and magnet, so we understand. Some of this stuff is created not on purpose, but naturally. When they found that temple and you could tap the quartz, okay, or tap the granite, I'm sorry, the granite, the quartz in it. When you could tap it, what happened? It started making sounds like a drum, right? You get over and you find rocks in a river. You could tap them and they make a sound. You move them out of the area, they won't make that same sound. They won't ping like they do. There's a giant rock on the other side of the world, and in the area it's in, you can take a hammer to it and it'll ping all day long. You move that rock and it won't do it anymore. What's going on? Well, they're struck by electricity. When the electricity went through it, it changed the field altogether inside of it, the structure, the atoms, everything. But it's only in where it was originally placed when the lightning struck. As soon as you move it, they realign. But then you go back to it and put it back on there, they line back up. It's a fundamental understanding of what you do in an electric magnet. In an electric, you need that constant flow. That's why you put you put the aluminum foil over it because it makes a constant flow. It changes every time it goes through there. Those little arrows go in the same direction, and it keeps it going, keeps it charged until it's permanently set. You think it's permanently set as soon as it dries. It's not. It takes 30 to 60 days to permanently set. But when you hit it with super high voltage, millions of volts like lightning, it tells you a quick answer. It's set automatically and it froze back automatically. It means that somebody, whoever was playing with those pillars in that temple, either it got struck by lightning or they did it intentionally and they knew about voltage and how much you create in order to shift that field, which is a very scary proposition, knowing that the olden times they already knew how to do this. So, yeah, it's pretty interesting how that worked, man. Cool. William wrote a paper on it, man. Send it to me. I'll put it out. I'll put it out on the podcast, man. I'll do my AI voice and I'll read it, and we'll put it out there. It'd be pretty cool. If you're interested in that, we'll play it on the show. I'll do that, man. Oh, White Hills, Hills of Wilshire. Not sure what that's in reference to. Oh, lightning forming hills. Okay. Yeah. Like I said, William, we'll put that up there for you. We'll do that. Absolutely. Yeah, pretty cool stuff, man. It all comes down to the fundamental understanding of what energy actually is. Energy is those four fields. Let's just tell you that. And it includes temperature. So I should say 5. So there's the temperature differential that goes on in each system. You can't get away from it. I see a lot of people out there, man, they literally don't understand this. So they'll put their MOSFET, okay, in a heated area and think, oh, it's just fine. I'm not changing the frequency of it. Well, yeah, you are. Yes, you are. I go over to my ZVS, man, and all I do is go over to the heat sinks to it, and I put my finger on it. The capacitance in my body will change that frequency immediately. You'll automatically start seeing lights dim out of my Tesla coil. And you go, well, why? Because my body capacitance works on my Tesla coil. You think it's not going to work when I touch that MOSFET? You think it won't be something that's going to add more energy to it and blow the thing up? I mean, seriously. So you know the temperature is playing a role in it. Why do you think I put fans on it and cool it? It may not need it, but I put it there anyway because I want to keep the temperature regulated. I know it screws up your system. Now, if it's in such low voltage, will it screw it up? No, because you won't notice it. Again, the difference between low and high voltage. When you're building a system in high voltage, yeah, you're going to see it. It's going to come right out at you, man. It's going to come right out at you, and you're going to see it clear as day. Way interesting stuff, man. It ruins your system in seconds, and you don't even realize it. So many people are oblivious to it. They have all these controls in their environment, except for they don't control their electricity system. The one thing they're using to drive everything, they don't control it. As soon as they do that wrong, they screw it up all the time. Let's see. Plus it with the magnet wire around it. You got this. I got to go back to work. Please try. Let me know if you need nothing else to show me. Okay. Not a problem, man. We'll see if they got something like that. I'll go down to like the cooking store and see if they got a rolling pin or something like that. And which I would imagine they do, that I could just take apart the two sides and then we can spin the wire on it. That's not a problem. They used to coat the transformers in beeswax, and they worked a lot better. And they put off a higher electrical value because the electrical value stays in the beeswax. It's creating electric right there on the transformer itself. So it'll change the value of it. Now they don't use that stuff, but old school transformer builders still will. They understand what it's doing. You go, well, you use beeswax in an electric. You're coating a transformer with it. Therefore, you're charging it up, right? Not a problem. We understand the fundamental part of why they used it. Yeah, PVX. They put that in there too. I seen that PVS was beeswax, right? PVC. PVC is a little different. I didn't see that in there. Paraffin wax or whatever they want to call it's in there. Anyway, they put stuff in there, man, make electrics. I'm excited the way Sean's going on his project, man. He's been sending me a lot of stuff in there to make electrics and the way he's doing it. And I'll be honest with you, his best ones look like oatmeal cookies. I find it ironic, man. He went from perfection to little things, and he'll show you when he comes on, man. And then he built some other ones, and I don't know I could talk about it yet because he didn't give me permission, but it was so cool in the stuff that we talk about. I hope he presents it because it's going to be just epic when he does. So I'll leave that up to him, though. Yep. Waxes and resins, yeah. Or rosins. I think it's saying resins have unique properties. Yes. Resin's good to hold things in and keep it compressed so that things don't move around, but you will build evos in them and then create little holes everywhere. All depend on how you run your system. What about a quartz Tesla coil? See, quartz would be great, like I said, the timing circuit. So we'll have to get some quartz oscillators and set those up. But I think that would be good. Right on, Brendan. Giant speaker for something nice. Yeah, beeswax. Yep. So the quartz crystals around it, man. I hope you don't blow that thing up right away. All I got to say is if you're going to put it in the center, make sure you isolate it from the sides and then make sure it's off when you do it and you put it in there. I'm excited to see it, though, to be honest with you, man. I have another circuit sitting right here. If a thing blows, I'll mail you another one. Because I really do want to see your experiments, man. Because I know you're all into that crystal, and so am I. Like I said, put it on that wire to it with the rod down the center, wrap that crystal. I want to see what it does. Anyone to reach out to Norman Wooten yet? I haven't. To be honest with you, no. Let's see. Top to bottom of the bulb and wrapped 32 gauge coil around it. See, plasma was cool. Yeah, you know what? I'll pull up your site, man, and we'll show some experiments going on there. Because you definitely got some cool stuff, man. That light bulb one got me. I haven't been able to do it yet. I haven't had the time to build the STL for it to hold it up there, and I don't think I have a piece of PVC the same size. So, talking about the other guy, you can mount it upside down. We're going to find out, aren't we? Definitely going to find out. I still think you're in a lower frequency. You need a trigger cert and a frequency generator and the wire wrapped around it, and then put it in the water. You may have a better thing. Let's see. Better talk to him while he's still alive. He's as old as Trump. He's in the 70s. Yeah, turn it over. So many cool people, man, doing cool experiments, man. I love it. By the way, guys, you see the Tesla coil over my shoulder, man. I'm selling them in case anybody wants to buy one. They're $300, man. You get the PMP circuit, you get the Tesla coil, you get it all ready to go. Everything except for your power supply, which you can pick up from Amazon, which I would love for you to do it that way, only because you get a warranty with your power supply from there. You're able to return it, and trust me, these Tesla coils sometimes tear power supplies apart. It's good to have a warranty. So, oh, that'd be cool. Can a crystal be grown around a shaped memory alloy like nicotol? I'm not sure what that word is. I don't know. To be honest with you, I don't know. I know they build out in shapes because of the frequency that's put into them. Oh, let's see. All are amazing. That's true. Resonance at molecular level versus macro quartz. Yeah. Well, that's what it is, to be honest with you. It's the difference in the two. The fringe family. Yep, that's what it is. It's all cool, man. There's, there's Paul. Right on, Paul. Let's see. The shape of memory and metal. So think about it. If you use some kind of aluminum bismuth, man, and you had memory in that thing, that'd be awesome. Okay. Some kind of quartz setup. Yeah. Build a super speaker. I think he's talking about something else, man. Tell you what, Bedini did some cool devices out there, man. If you ever pick one up, and I don't mean as like over Unity devices or anything like that, or as schoolgirl circuit. I'm talking about his amplifiers, stuff like that. If you ever have a chance, Brendan, pick up something from Bedini like that, that'd be cool to see. Naito, oh yes, good experiments, but they must be grounded at fixed temperature. I don't know anything about that one. That's cool, man. Yeah, pick something up like that, man. I'd love to see it. Those things are cool. All right, give me a second, guys. I'm gonna pull up channel real quick. Let's see what we got here. Sorry, guys. Give me just a second. Here we go. We're going to go from this one. So I got to make sure it's music. If it's music, I've turned it off. So look at that, though. It's just a normal light bulb, huh? That's pretty sweet. So he's got a hole saw under there, and he's got the light bulb. Yeah, we saw this one. Let's see what the other ones are. So let me go over here. As soon as he puts more power on, man, that's so awesome. Oh, look at that. Oh, look at that. He broke it out like lightning. Let me see if I can't catch that spot. Look at that. I don't think it's hitting the center of that bulb at all. It looks like it's sitting off from it. Dude, that's cool as heck. This is all Dennis's. The bulb's got the same miles on it. Nice. Yeah, he's got some good shorts, man. This is cool. I go ahead and play it normal. It's like lightning in a bottle. Look at that. He's got a spark gap on the side of this thing too. Oh man. Yeah, this is awesome. Let's see. See what else he's got on here. Dude, I love those sparks in there. I can tell you I'm a sucker for sparks, man. I'm gonna have to slow that down. So let's just pause it and look at it. Ooh, look at that. You can almost see an inner ring in the whole thing, man. Right inside the light bulb. Look at that. Yeah, dude, you're getting all kinds of props in here, Dennis. You deserve it, man. Good job. Nice. Go and play that regular speed again. Dude, that's definitely. Oh, hold on. Hold on. That's definitely putting an inner field in there. I mean, look at the purple on the inside. Like that shouldn't be a reflection. That looks like it's putting an inner field in it. Very low voltage. The spark gap changed it. Ionization changes things. Yeah. Nice. Huh. Wild. I think he's got one more on here. Ooh, look at this. Oh, hold on. He put it in slow mo. It's so much better in slow motion, man. So cool. See, there's a mini superhero in there. Oh, oh, look at that. Ooh, that one's cool. Oh, that's awesome right there, man. That's like next level, bro. Let's say this, man. Dennis, you definitely got it going on. Definitely got it going on, Dennis. Way awesome, brother. Way awesome. Yeah, I think we all got to try this. Oh man, Joe's excited, man. I sent Joe a coil, so he's gonna be doing experiments soon. He's got a cool one. Joe, you mind if I play that? He's got a cool experiment he did. All right, Joe did this one, man. So he's got that little zappy stick thing, man, that Sean gave us. I think Sean likes to torture us a little bit. He's got quartz in there. Man, that orange looks good in there. Is that a spark on there, Joe? Arcing through the glass. Oh, that's wild. Now I've had that. Okay, take a look real quick. As you see the bend of this thing come down, the orange, it looks like there's a fire right there. Inside of the actual glass tube, in the orange, it looks like it has a flame in there. Yeah, dude, that's a flame. Nice. He's changing it by changing the capacitance by touching the outside. Oh man. I don't think Joe owns horses. Oh man. There's the flame. He touches it. Look at it, brightens up. Nice. Oh, that's so funny. He goes, "Oh, that was his yeah, stuff urine after the hot sauce." I'm gonna tell you, man, I got away lucky. Okay, little burn on the next day, but that's about it. And then it went away real quick. Man, that hot sauce got me, man. Although I'll tell you this, for a guy that doesn't eat hot sauce, I think I did okay. It didn't kill me, and I recovered after just a little bit of time, and we did all right. So what definitely worth doing again at some point, but not right now. My kids, by the way, check this out. So I made those wings, and I put like maybe what 6 or 7 on my plate. And my kids annihilated the rest of them. They go, "Oh, there's cooked wings in here, dude." They went right through everything. The hot sauce was fun, man. All fun and good fun, man. Oh, I told my wife to just use that extract in little parts because she likes hot sauce and stuff. So I kind of want to see what happens, man. I told her let me know when she's ready to try this stuff. Dude, I need a good laugh. I burned my face off. Everybody got one. So now I just got to see the reaction she gets, man. You hear it all the time. Oh, you don't need hot sauce, man. So, your wife tells you, oh, you're wimping this and that. And I go, okay. No, I stood up to the challenge. Get to it again. I'll tell you what I will do. Okay. I will go ahead and we're going to eventually in the future give away another Tesla coil. We had Miles. He said he couldn't take the Tesla coil. He lives in a different country. And the whole shipping thing would have been a nightmare. So he didn't take the second coil. So I'm going to go ahead and say that Joe and I will figure out an event and we'll give away another Tesla coil here in the future. And I think that's only fair. So I don't know what it's going to be yet. Hopefully it'll be something fun. The wings were fun. I'm sure Joe will find some medieval thing to torture me with again. And he'll blame it all on me. Of course, it's my idea, but whatever. You know what I mean? And then we'll do it again. We'll have to see what it is. I'm sure he's got something up his sleeve. That's for sure. Yeah. Nice. Yeah. Yeah, man, we had fun that day. I'll be honest with you, man. That was a great show altogether. It was fun. We cruised into everything, man. We learned a bunch of stuff, had a bunch of fun, burned our faces off, and then we started talking about more UFO stuff and everything else. I thought it was awesome. I mean, who does that? Oh, yeah, I'd say we drink some beers or something, man, but I don't drink anymore, so that wouldn't work for me. I don't know what we could do. We'll figure out something. I'm sure there's something out there that's diabolically hot that we'll have to eat some kind of food or something, and it'll just send a bunch of steam out my ears. Send an email link to me for sure. I'll put it in there. There's my email, guys, right there. You got something cool, contact me. You got a paper that you wrote, you want to put in my AI voice, and then we'll all listen to it. Absolutely, I'll do it. I don't have any problem with that, guys. I'll put it up on my podcast channel as well. I think that kind of stuff's cool. If you want to contribute that way, you want your message to get out there. If you want to come on live and talk about it, we could do that too. All depends on your comfortability level. Nice, man. I appreciate it, brother. Yeah. All cool with all that stuff, man. You got something you want to get out, by all means, man. Get it out, check it out. You know what I mean? We'll all talk about it, man. Nice, easy going environment. No problem whatsoever. How's Sean? I talked to Sean just recently. He's been good. Has some problems, man. Sometimes, you know what I mean? We all do. Have to take some time off. But he was at it, man. Like I said, he's got some cool stuff, and I'll wait for him to share it. Totally blew my mind when I saw it. Gravity well incoming. Nice. Yeah, that thing gave me an ill effect on it, and I had to stop the project for a while. Something I'll talk about later when we get into it. But nice. I do want to show you guys something, though. It's on my channel. I think this is, I'll just play a very short clip of it. And what it is I think this is the way I'm just going to do my videos going forward. So you can see me on there doing stuff, dude. I'm doing an experiment, right? Most of the times I'll just do an experiment, sit behind the camera and tell you what it is, or I'll use the whiteboard and tell you exactly what's going on. So what I'm going to do from here on in is I'm going to show the experiment and explain it at the same time. I've been going back and forth, man. I don't do quirky skits. I don't do anything like that. I usually just kind of show things as a teacher, man, things like that. So I'll play a couple seconds of it, man. You can check it out. Test the coil. You can see the light lights up beautifully. As you can see right here at the end, we have a plasma breakout. So we're good. We'll take this, we'll put it out of the field. Now, it lights up right next to the orange, not a problem. Why? I'm just exciting the water inside of the orange. That's what I'm doing here. Now you could turn the energy up if you wanted to and get a brighter glow. We'll just go up to about 13 volts. You see our breakout got higher. My energy gets better. There's no problem getting energy at a distance in this field. Real bright next to it. All we're doing is exciting the water inside of the orange. But the orange is 360 degrees of water. So my field itself is now 360 degrees. I just changed the geometry of what I'm doing. It builds out all the way around it. As you can see, it lights up beautifully. We'll try a different bulb here, a little bit smaller. Lights up no problem, like daylight. Why not this? Needs a little more energy to do it. Still lights up. What's kind of cool about this one is the color of it actually changes. And it might be because it's a brand new bulb. Anyway, that's just kind of want to show you a little bit of it. I have it on the members portion right now, but it's the format I'm going to go to, and I think it's going to be a lot better. And that way, you kind of get both sides of it. We do, I'll do a little whiteboard action when we do that. We'll do the experiment. I'll explain exactly why I'm doing it. That way, nobody's confused. There's no question of, hey, that looks cool, but what'd you do? And now it comes out in the perfect format where you go, okay, I can see it, do it. But less stress on me, man, because I'm not going to be over there doing funny skits. I'm not going to change the camera angle a bunch. I'm not going to do all those things. It's just not me. I've been fighting with this for weeks. I think, honestly, to do that, yeah, I'll collect all the times I zap myself. That'll be hilarious. I agree with you. A little blooper reel. every time the car comes by and I start cursing at it, yeah. I mean, I got an insulated garage door, but it don't stop the vehicles come by. You hear a motorcycle come by every once in a while or something. And then sometimes, man, I'll start screaming at the top of my lungs or something to turn on the washing machine over in the other room. And it's like, man, I guess it'd be funny to see all that. You may have a lot of bleeps in there, though. Yeah. I was thinking, man, if I didn't need to vent out my garage so many times with all the little fires and stuff that goes on in here, man, I wouldn't have a problem walling it off. But yeah, definitely need that thing for some things. You want to see the frequency of that little device you showed me? So hold on a minute. Let me see if I can't pull it up real quick. Sorry. All right. This thing, man. Give me a second. So there's the device right there that Joe and I have. Mine's turned into a little mini Tesla coil because I cut the top of it. But this is the exact device right here. They have different colors of the gases and stuff that you can get. This one looks blue. That looks pretty cool. I have more of a purple. Excuse me. Joe has an orange one. And I believe Sean has the purple one, but blue would be really cool too. Definitely worth the money because the gas is in there, man. Those bulbs would cost a lot more than that. What, $30 for this device? So yeah. But yeah, I could check the frequency of it if you want. I could do that. That's not a problem. I should make a video just on that little zappy thing. That is so cool the way it runs through those boards and stuff, man. It does the frequency. Way awesome. They use it for growing your hair or stimulus on your hair. Yeah, I seen one online. Let me see if I still have the picture. I don't think that. No, I don't. Oh man, I might have it. Hold on a second. They they made an old school one, and it cracked me up, man. All right, check this out. So if you look at this thing, okay, this is an old school one back in the old days that they the guy that was out there on the street, man, or the I don't know, doctor, I guess you would call him, had it. Look on the bottom right there. I don't know if you can see it, but the bottom right, I'll go to full layout, man. They clearly, man, they got a butt plug device over there for this machine. You can't make this stuff up, man. They were sticking this up, you know what, and getting excited. This thing shocks the living daylights out of you, man. I don't understand that at all. But it's there. I mean, you can't hide the form. They took the time to shape the glass to put this thing in there, man. Like, what were they thinking? Dude, that's a alien doctor kit. Nice. Yeah. Maybe that's who's coming in the house in the middle of the night, man. You think they're aliens and it's this stuff. They got their probe ready, man. They're getting you. Oh, really? A cure for female hysteria. Well, I don't know that it's going to work. Oh, 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 man. Who measured it? Must be made in Germany. Oh, oh, Joe, show just hit 2 hours, man. Yeah, we're getting there. Dude, I'm sorry, man. Oh, holes. That's right. Oh man, throw it up if you got the emojis, man. Just throw it all in there. Let it all out. Oh my god. Yeah, dude, they got all kinds of stuff, funky stuff, cures, elixirs, everything back in the day. I just couldn't believe they had that. It's an enema blaster. Wow. I mean, look, I understand if they had a vibrate machine, but that thing was clearly zapping device. What are the new tools for engineers? Oh my. That's so great, man. Holes. Ah. Oh, the purple prober. I don't even know what they got, man. Maybe it turned funky colors like a Christmas light bulb or something. It's just, dude, that's too much. That's too much fun to laugh at. Okay, sorry, I had to. Yeah, man. These things these people come up with. I just don't know when they thought that was a good idea. Like they knew it zapped somebody. Oh, you're asking for yourself, what tools do you recommend I have before beginning these projects? I'll be honest with you, man. Get one of those little zappy devices. You want to go cheap, get a little tester coil, buy a tester coil like I have, whichever one you want. Simply just start doing the projects, man. Get a Slayer exciter like the one I got on that PMP, man, and then run all day. That's what you want. You want something that's going to give you entertainment all day long. That's what you want. Anytime you want to go start it up, not a problem. You don't have a time limit on it where it blows up, things like in that nature. That's all you want. That's all you want. Then when you get into it, you go, so the Zappy thing was the thing on Amazon for $30, has the different colors on it, man. So I'll show that again real quick. Yeah, that thing there, man, really fun. You can convert it by cutting the top and then putting a little rod thing down the center of it, and it'll turn it into a Tesla coil. Sean showed me that. Really cool, really cheap, kind of fun. Can zap some things. I call it a zappy thing because you bring it over stuff and it shoots a little bit of lightning out of it. You know what I mean? A little bit of voltage and gets a good spark. But yeah, those are fun. Those are pretty cheap. That's $30. It's not, and the gas tubes are definitely worth it for the price. That's for sure. Because they're usually $50 or something like that just for the tubes. Well, they're different kinds too, but yeah. Anyway, not the adult toys part. That's your own business. Not going there. But for Tesla coil stuff, man, just get something out there that you can play with every day and kind of do some experiments with is awesome. Bulbs, yeah, dude, I got a bunch of cool bulbs. Like, if you saw the member thing, man, I put it out there. I literally picked up a bunch of boxes. Let me see if I can't just turn the camera real quick. That big pile right there is bulbs. That's all fluorescent bulbs over there. There's like a billion of them, man. It's so cool, dude. Like, this guy had a bunch of them, man, hooked me up for all that stuff. Really cool. Now I got a ton, man. I can start hanging them on the walls, do them in different colors, turn on Tesla coils while I'm doing the show. Yeah, that's pretty sweet, man. Thank you. That was really awesome. This thing got messed up somehow. There we go. There we go. Change color back. Yeah, I'm trying to do that spark test, man. I'll do the spark up one for sure. I just got to set one up. Yeah, right on, man. I hope to help. I mean, I know it's kind of vague in what I said, but just anything that sparks, man, is fun to start with. I mean, dude, I like these coils because it over my shoulder, it puts out a ton of power. What's up, Crypto? Crypto's got some cool stuff going on, man. I didn't see the episode yet where he shows everything, but I know he's got some cool stuff going on. I keep reading all the messages that he sends out. Hmm. Yeah, free ball with every Tesla coil. Yeah, they'll probably break. That's for sure. If it was a little small thing or something like that, I wouldn't mind doing it. But these are 2 foot long at least. Gonna have daylight in my yard. Well, you know I am. I'm gonna use every one of these. Let's see. I have a membership to the channel. Some of your lectures, I take notes. I feel like I'm ready to begin playing around and wanted to be safe. Yeah, a lot of it's safe. I'll be honest with you. Like the testicle I use is pretty safe. Um, you just have to be aware. Just be aware where the fields are, and don't be too close to the coil when it's on. Like if you put your face up to it, it's a bad idea. But keep your fingers away from the wires that come out of it or the sparks, and you'll be fine. Most of it, man, it's pretty easy going. You don't need an oven mitts or anything like that. You can use electrical gloves if you want to. Sean has a real nice thin pair that he wears for this kind of stuff to be safe. It's always a good idea to wear safety glasses, though mine fog up because I'm fat and they do. I don't like to use them. I couldn't even use them while running my table saw. I they would get my hands cut off if I tried to use those things. So yeah, that's where I'd start, man. Wherever you're comfortable, where you want to dive in, jump in. That's all I would say. I don't think that any commercial stuff puts anything out powerful enough to really harm you, or else they'd be getting lawsuits everywhere. The stuff that I do has the potential of doing that if you use it in the wrong way. Yeah, be fair, the holes. High frequency, low current, perfect, perfect. That's what you want. You don't want high current in anything. Very low current. Never want to use microwave transformers. Those things, a lot of people pass away with those things, so those are bad. Anytime I would use one of those, I'd have a wooden box to put over top because I don't want to be anywhere near them. Okay, so let's see. If you fan tightly, like fireworks, does that mean the flow? So fire can be bent, and yes, you could change it. There's videos on it out there. There's also stuff on, man, some cool stuff, some flames. If you put different ones in different colors, you could spin it. Makes a cool swirly field. I was looking into that for a while. They have frequency tubes out there. You put the resonance frequency in a quartz tube, okay? And then you could put another tube inside of it and make frequency like this. You could put another tube beside it and darn camera, one like this, and put two different frequencies in there to make a beat frequency. All that you need for that experiment is you need something to heat it up. So you need something that puts out some kind of amps. Then you need the little piece that goes in the toaster, that piece of metal right there, those strips that are in there. You grab one of those, take a quartz tube about this size, about this tall, you put it in there, and based on the distance that you put it in there, it'll make a frequency actually inside the tube. And then when it does that, you can make that resonant to another tube. That's just wild, man. It's a cool experiment to do. You can work on beat frequencies that way, which basically means that you have one in resonance and you can get another one close to the same resonance frequency, and they'll create a beat between the two of them, which actually works out perfect. I've seen that a lot in operation as well. That's cool. That's more like the Viamana. When you see it and you see those tubes coming out, there are 4 tubes that come out of the Viamana, and they have one set at one height, or one pair, I should say. One pair set at another height. So they're getting a beat frequency between the two. Not quite oscillation. Oscillation happens between two pipes. Two pipes are in oscillation, but between all four, there's a beat frequency going on in there. Really interesting stuff that goes on in there. Yeah, dude, there's so many experiments out there I'd love to be able to financially afford to do. I'm getting there. Definitely getting there. I'm working on a cold energy circuit right now. And as soon as I'm done with it, man, I'll put it out there for everybody to see. But I wanted to put it in the rodent coil. I know that Ben out there does a great circuit for regular energy, and it works really well. I wanted to do the cold side of that. So I bought all the parts and did everything, got my neons, got my two transistors out there, got a nice heat sink and everything for it. So shouldn't be long, man. I'll have it together and we'll be able to see it. We'll test it out, see how it works, see what's going on. I wanted to use batteries on it instead of running the wall electricity. I just wanted to make sure and confirm, see if it's the same or not. And I may have it better because of chemical process in the batteries I'll have to use later when I convert fields with a bunch of cap banks that I built. So that's going to be cool as well. But if I make the circuit and it works, man, we'll put it out there and we'll get it going. A couple of people inquired about Ian's cap bank. I just want to let you know, when I am able to build it and do everything with it, I will make it and sell it for people to be able to buy, because I think that's really cool. When you're working with the ZVS Tesla coil, it's a game changer. When you're working on resonance on the back end of a circuit, game changer, absolute game changer. Everybody should own one. I really do think that. So I'll set one up, a small version and a large version, both, because I think that they're necessary in doing some of this. Someone also asked about a DVS Tesla coil kit. I'm working on it. I do not like the heat sinks and the way they work on the standard ZVS that I buy off the shelf. I want to convert that where I could put two fans on it and create a STL file for, out of plastic, so that we can put the fans on there and get a better heat sink on it. That way it'll stay cool during all of our experiments. And the fan that I actually use for my PMP circuit works great. It works on all the high voltage fields. So it's a perfect fan, never shut off on you in your ZVS. That's what we need. And that's what I want to be able to create before I put it out there. Now, in talking to Sean, there's a couple things that I'd like to add to it and build my own circuit. A small capacitor for a startup is what I'd like to do. He's done it on another ZVS, and I think it's a better feature to have on here. So we'll add that to a board that Sean and I come up with, and we'll put both of us on there. I think that'd be awesome, where it has like a start on it, so it's not a hard start. There's a button to turn it on and off. We're gonna add fans to it. I think that's the way to go with one of these things. I want to be able to add something more than buying something off the Amazon shelf where you just pull capacitors off and put your own on. I think that's cool and all, but being that we want to build it out and make it a little bit better, I think getting it cooler, making it run for longer. I don't blow up my ZVS anymore because I'm not doing crazy things with it right now. It's lasted a really long time, as long as you don't do crazy stuff. Now, some of the things I do in here is absolutely insane, so I tend to blow up a lot, especially when I first started. But yeah, I think it's the way to go. But that cold energy circuit, as soon as I give that to people, man, it's a game changer. Then you can just start building rodent coils. You can start building geometry coils, whatever you wanted to, man. It's done deal. It's a perfect circuit when we get there. Oh man, I might use MOSFETs on it. I have both MOSFETs and transistors for it, so we'll see which one works the best in the system. Yeah, that ZVS, you if you want to use AC, you got to use a Variac. That's kind of the hard thing. How did I say you can't until you got to buy a Variac? I mean, that's a $120, $140 proposition on the Variac itself. And again, you want a warranty on this electrical power source. You want a warranty on that. But if you want to do DC in it, it works great for DC. As a matter of fact, it teaches you a lot. PMP puts it in perfect tuning every time. What if you don't want perfect tuning? You see, a lot of people think you want it every time. You don't. In some systems, you want the frequency to be more than the energy. And sometimes you want to just tune it down. Now, when you tune it down, what's the advantage of that? Then it comes out as cold energy. You no longer get the rod hot. That's the advantage of the ZVS. You could tune it. The caps that you use, if you use the regular caps, and Dennis does this, he uses 3 of the regular caps. I don't think it's 4. I think it's 3 in series, not in parallel. They come in parallel. You got to take them out, put them in series. That just means one cap, then the next cap, then the next cap, right? You just go in on this side, then it goes, this side's connected to this side, this side's connected to this side, and then it goes and out, right? Pretty simple. I use a high frequency capacitors in mine. What's the difference? When you get to AC, the difference is a 9-inch spark like this. When you're doing the other caps, because they're slower, high frequency caps get you out to about 12 to 13 inches of spark. Biggest difference in the two is the speed, how fast you could do it. That's about what you're looking for in there. Oh, transistors and MOSFETs make you ill. Well, use spark gap. If you learn that trick, man, you're going to be getting far ahead. Spark gaps are awesome. So you just got to make sure you get them nice and tight. One of the problems and inconsistencies with a spark gap is how you build it. If you don't build points into the ends, then you have trouble because it's not consistently hitting the same spot. And if you've ever built a trench diode, which is basically for a radio, you know that you take a lighter, you put it on one side of a razor blade, and it'll make a one-way diode. So think about that when you get a spark gap. Anytime that you get too much buildup on it, you're making a diode that goes there. What if the diode's in the wrong direction? That's not good at all. You need it to be consistently at the same point in order to get the energy to flow through properly. Points on it is imperative. You don't want this thing going all over the place and sparking at different areas every time. You want the same spark. Yeah, consistency. You want to play music through it too. I have a music circuit I can add to the PMP circuit and the NPN circuit. For the ZVS, I don't have one yet because it would require rebuilding the board. So I haven't been able to put it on there. But ZVS for the other ones, we can work on putting that in there because it's no different than using a duty cycle at that point. And using the, how do I want to say it? We'll just use a trigger circuit. We'll be able to put it right into a trigger circuit because trigger circuit is simply low voltage and high voltage. Your energy passes straight through between the voltage, right? So it goes in, goes out. The trigger portion goes in a very low voltage. It basically adds to whatever's going on this. So it'll have the ability to change the frequency on the high end with using a low end energy. So we could basically use you can hook it to your cell phone and play music, put it in there on the low end. It adds to the energy on the high end and it'll change it. So if you wanted to do something like that in your Tesla coil and play music out of it, boom, there you go. That shouldn't be a very hard process to be able to pull off. We could put a circuit in there and you can play music out of it. Matter of fact, I'd like to play a little AC/DC Thunderstruck as I'm doing some of these experiments. Be a perfect way to do it. Nathan quit ghosting me. What do you got going on? Tim Tron, I'd love to talk to you in person. I've been looking to speak with you, man. I really appreciated the last conversation we had on Mike's channel. So much information in such a short time. If you'd like to be a guest on here, man, I'd love it. Or I would do a personal conversation with you, man. Dude, Tim, I think you're awesome. So I was looking forward to it this weekend. And Heliarch, I sent him a message and he didn't send me anything back. So, man, really, really smart person Tim is. So, God, it was such a good conversation in such a short time, man. Thank you for that, by the way. I look forward to the next one. Nice. Yeah. Just let me know. Here, I'll put my email in here. There's my email right there. So yeah, just hit me up, man, and we'll set it up. You guys are both busy? Right on, man. Yeah, let's do it. As soon as you guys are ready, man, let's do it. You know, there's so much information that you guys have and over Unity systems and then the Meg, and then beyond that, we were talking about the ringer device, which was the bit. Oh man, when people really understand the resonance and what you're doing, it really changes everything. It changes the perception of how this stuff is working. We're in such a bad area of perception on this stuff, man. I think it would be really super helpful for that. Right on, man. Yeah. Well, just you know what I mean, Tim? You and me and Heliarch, man. However you want to do that, and we're good. Nobody else, man. Just have that personal conversation about it. I think it's really cool. Have I tried the Bluetooth speakers in a FET for frequency divider? I have not. The PNP transistor that I use in my Tesla coil is actually from an amplifier. And they sell them in kits with the NPN matched to it, but that NPN has nothing on that PNP. There's a voltage difference for sure. So there's a max that it could go, and it's completely better. It changes because the only resistance in the circuit is the resistor itself. That's the only heat in the circuit. So it's pulling different. It's pulling in the voltage first instead of the amperage first. So it stays cooler in operation. The NPN always pulls the amperage first, man. So it's always hot. I don't like that. And it ruins the voltage when you go to use it on your Tesla coil. It's 10 volts less. I get the same exact numbers, the same exact everything. It's 10 volts less. Huh. You sent me an email? Right on, man. I'll check it right now. Nice. I got the email. Did you guys want to come on now, or do you guys want to set this up for later? So, yeah, that amp that was a game changer, man. Finding that circuit, I'll tell you that right now. Totally different, man. Totally different view. So, I love that PMP, man, but I don't like the resistance in it. So he just got home. Well, let me know, man. As soon as you're ready, I will send the link. So yeah, if you want to come in now, I went ahead and sent you the link. If not, we could do it another day. Just let me know. That's awesome, man. Totally awesome. Oh man. Yeah. So basically, man, I was building these testicles with Z44, right? Thing is an absolute piece of junk. Dude, my soldering iron was blowing them up. I had a little too hot and it blew them up, man. And I'm going, man, why is this thing not working? I hooked it up the way I normally do. Well, because my soldering iron got too hot, blew the whole thing up. Oh, Joel, dude, Joel's awesome, man. I watch his show a lot. He's got okay on his show right now. He's doing a circuit. Oh man, let me think of the name. Don Smith. He's doing the Don Smith, and he's putting different things in there, and he's getting unity out of it. The last time I saw it, and I could have been better since then. Dude, Joel is amazing. He has an understanding of this that is just out of this world, man. He was on the show a little while back, man. Got some awesome experimentation going on. Been a fan of his channel for a long time, man. Yeah, Joel's great, man. He he goes through everything. He tells you everything. He tells you like it is. He shows the experimentation step by step, man. He does it, and you're like, okay, now I understand it. Now it's presented in a way for everybody to understand. There's not a lot of complicated terms there. Keeps everything down to earth. Love that. Absolutely love it. Yeah. I think we all, to be honest with you, man, I think everybody watches this show probably watches his. Yeah, I don't know about you, Simple Man 911. He's definitely not that. Watch the video if you haven't yet. I will. His new one. Sorry. Vanna Bedini, not looping with cat banks, open circuit, but learning. Bedini knew it. He knew what he was doing. He transformed that battery for a reason. Right on, yeah. Dude, I think we all love Joel, man. I gotta call him up and see if he wants to come on again. So, yeah. Yeah, that's the system he's working on, man. He was doing it, and he basically showed used a coil, took a half in not half of the distance, but it was a half wave of it, and put it on the back end and used it as a ground. Then he built out coils on each one of them to be resonant to that coil itself. Totally blows your mind, man, when you see something like that. And it all has to do with radio frequency, and that's all it really was. But that was amazing because he was able to do it in a way that was understandable. And he spent like 30 minutes talking about it, I think, and totally awesome, man. Totally clean work. Loved it. Yeah, I agree with that. You know what I mean? We'll have him on again, man. We'll see if we can't get his numbers up along with ours and get everybody to rise together. Bernie's been real instrumental out there, crypto, and getting my channel up and going, man. He's put me on several times, and I really appreciate that. When I first started out, and it really helped me get going. So thank you for that, crypto. Really awesome stuff, man. Yeah. So yeah, we got some cool stuff, man. Yeah, we got some cool things coming up, man. So, like I said, I changed the style how I'm doing it to make it a little easier. We'll get into some more experiments. We got the coils out there, man. We'll be able to create some cold energy and going in them. That circuit's gonna be amazing. It tricks it because it takes out the resistor and it puts the neon light in there. So you're now, instead of building heat and keeping heat, it's burning off the heat. See, there's a difference in that. It doesn't have a chance of creating any back EMF in your circuit. It's not a build up and stop. It's a flow through, but it's using some of the energy. So it's a little bit of a different concept, but it's able to keep the energy cooler. Now we'll be able to trigger the circuit because it never really enters the whole MOSFET. See, the resistor does. Resistor goes right into the transistor or MOSFET itself. The light goes right over the emitter and the other one, not the base. It goes right over to the two right there, the emitter and collector, and it basically creates it without having to go through the transistor itself, which changes the amount of energy going through there. Really neat concept, man, and how it works. So, I will accept Tessico in return for some help. Please. Dude, I'll take care of you, Bernie. You just have to let me know what it is you're doing, what you need, dude. I'll be honest with you, man. That little frequency circuit and that trigger circuit for the experiments that I saw would be perfect for what you want. You change the frequency of anything you want. That little 5 voltage deal, man, when you do that and you're breaking the stuff down, dude, that would be perfect for what you're doing. And it's dirt cheap. I mean, we're talking maybe 15, 20 bucks from Amazon and you got it. I mean, that's a sweet deal. I buy those things, man. I buy the trigger circuit. I think it was like 7 or 8 I got for like $9. And then the other one was $10 for 2 or $12 for 2 for the frequency generator. Yeah, I'll show you the circuit, man, and the parts you need for that. And it's real simple to set up. I used it on all my experiments. If you look on them on my shorts, all the ones I did with the magnet, and I got it to go in every coil and turn. That's the exact circuit I used. I don't know that you need a high frequency Tesla coil for some of that, but if you wanted one to break things down, you got it, man. You just let me know how you want it done and what frequency you're looking for. And then if you use the ZVS, you can kind of change the frequency. They're just going to be high. You may need a low frequency to do what you're doing. So think about it. Let me know. I'll send you the information. So all about helping people out, man. So I would love to get my hands on some of that Orma stuff, man. So I always had this thing. I told Bernie since day one, I want to make a capacitor out of it. I'm a little freaked out because of not understanding how to handle it at this point. Because I know a concentrated dose of any of that stuff was probably not good for me. So I'd have to take every safety precaution. But I'd love to use it between 2 pieces of aluminum in a capacitor form where I could just basically, you know what I mean? If I could stick some kind of a, not necessarily a needle, but you know, those plastic ones, and you suck it out and then put it in, that I would love to do. And then, yeah, capacitor some of that stuff up, man, it may be a game changer right there. So I'm sure Bernie knows how to make it all safe. Yeah. That would, geez, it's like a dream come true to put that kind of stuff in there, man. Definitely do that, man. So yeah, well, some of that stuff, if I'm not mistaken, it goes right through the skin because it's broken down into little parts. So that may not be the best thing for you. So yeah, we'll make a trade. You definitely got it, Bernie. Just let me know what you need. Definitely make that trade. Because that'd be cool too, because it kind of, I don't know if he's doing those experiments or showing any of them, but something like that would be yeah, it would be really cool. Yeah, goes through the skin. I figured that. I remember talking about it one day. I'll tell you what though, if we just use that little injector and we put some gloves on, make sure they're pretty good ones, I think we could be okay being safe in it. We'll have to make sure it goes nowhere and it doesn't leak. But I think we'll be all right. We can get that going. We'll just have to make sure that we put some kind of isolation chamber around it in case it explodes in there. You never know what happens when you put electricity through things, especially in that form. If it does some kind of transformation be awesome. If it just turns into a solid metal, same thing. Dude, whatever you can get out of it and it does some kind of anything, I think that's a win. You know what I mean? And then when we start putting the right frequencies in there, I think it'll change too. So you shoot lightning bolts out of your fingers when it absorbs in your hands. Oh, dude. Do you have a picture of that, Bernie? Dude, I'd love to see that. I always told you guys once I get Sean's coil and I confirm that that sucker does not come at you and that it basically, you know what I mean? It's a how do I say this? Not harmful. Dude, I'm going to make voltage fingers. I'm not lying, man. It's in my head, it's stuck in there. I'll make a backpack for it and everything. Um, that's cool. Dude, awesome. Dude, maybe next Friday when we're all on my channel, you could show that, dude. That no pressure, man. If you don't have it right away, that's cool. I don't want you to put that stuff on your fingers unless it's an accident or something, because that's probably bad for you. Maybe you could put it on the end of a glove or something, where it doesn't contact your skin and do it. It'd be just as cool. Heck, even a little drop on the counter or in a little petri dish would be awesome. I mean, we don't want anybody hurt. You had dreams of having that. That's awesome. Nice. Send him a wand for zappy fingers, man. Look, there's not enough voltage. So let me just tell you, I did high voltage hand already. I used coax cable and I used a DC flyback and I hooked it to my fingers, right? And I'm able to put it on there on a sheet of aluminum and go like this and make spark this big. The difference is, man, the DC flyback is more of a, anode cathode thing, where the Tesla coil is just bursting out energy directly out of it. You see, that's why it makes it cool, because then you get the emperor hands, man, and you can just boom with the lightning, right? But it's got to be safe. I mean, that would be the coolest thing in the world to be able to do that. But I won't do it if it's like my AC Tesla coil. Not a chance. That stuff's harmful. Have a piece of quartz and you'll fly. Dude, I got a big piece of quartz behind me. I bought a big one, man. Um, I wanted to do experiments with it. So has to be absorbed into the skin for the effects. It's like a supercharged static zap. Ooh. Definitely got to see it now. Crypto's got me going over here. I'm getting all excited, man. Love things like that. Yeah, AC's not good. It depends if it. That's why I want to see the field that Sean created in his Tesla coil, because I know he's using AC, but he flipped the field. So I want to know how it looks and works in real life so I can test it myself. He puts his cell phone right up to it, man. My cell phone is half broken right now because of all the fields Tesla I put it in. It's bad. It literally, man, it does not want to film things right or anything. So I had my other camera out on my tripod, man, and I had it at a distance, was to zoom in real tight because I didn't want to blow up another camera. Those things cost some money, man. So, and then of course, I still have it screwed up when I try to change the frame rate on it. So I'm gonna have to go back and watch the video and fix that, because I love the style of video I did. I don't like the frame rate. So, but anyway, hopefully I'll fix that. What was the app for the regulated chat and vids? Starts with a B. I'm not sure. I don't know if anybody else knows that. Got a pen to write it down now. What was the app for not regulated chat vids? I don't know. All the stuff in the chat, I don't have everything enabled for people to drop videos in. They usually just drop it in my email. So let's see. That's not exactly true. Spark gaps don't lower the amps. It really depends on how you do your spark gap, but you could raise the amps in your spark gap. Mike talks about that on his channel quite a bit. He gets a little more amperage out of his spark gap. It depends how you have it configured and what kind of energy you're running through it. But you could definitely get some more heat out of it, which would create more amps. But then there's a time where you take your spark gap and it normally runs at 240 Fahrenheit, and then you can get it to run at room temperature when you're in the right resonance. So really depends on what you're doing and then how you set it up. Yeah, John knows. Create more punch sometimes, yeah. Let's see. For the gap on the output of the secondary, not the input. So again, we're talking about the output. So how do I say this? The more resistance that's in your spark gap, the more amps it's going to pull in. Let's just put it that way. Anytime you have a higher resistance, yeah, you're gonna get more amps. If it flows faster, you won't. You get a lot more voltage out of it. You can't find his flux capacitor. You gave it away. Nice. Yeah, a little bit different when you're working with spark gaps, man. A little different cup of tea. I don't think you have anything to worry about on your Tesla coil, though, man. You're definitely getting more amps out of it. I can tell you that just by the way the voltage flows. Anytime that I see white in your voltage, I know your amperage is up. Your Tesla coil frequency will be really high frequency, so it'll be high voltage. As soon as I see any white go on there, man, I know you're getting amperage. I know you've already raised the amps immediately as soon as you see it because you're changing the color. You add more amperage, you're going to start going through every different color spectrum there is. That's the difference. You just have to change the amperage field in your high voltage and start changing the color. And then you're set. You know what I mean? You can see the colors of the rainbow. So, yeah, we watch Faraday for that. Just ask him. I'll ask him. Matter of fact, next time I go on there and just double check with him and see what he's got to say about it. Faraday's real good about it. He uses spark gaps a lot in his Renegade circuit. He runs that pulse motor and it runs spark gaps in there. He uses piezo discs as well for an amplifier because when you're running cold energy, you're not fighting against the magnetic field. So the piezo disc acts as an amplifier in the system. It's a pulse. So, yeah, think about it. You're going frequency, frequency, pulse, frequency, frequency, pulse. So you're going to add extra energy to the system. As long as you stay in the cold format, they work fine. And we've shown it. I showed it on my oscilloscope doubling in the field. And it'll basically go from 160 volts to 320, just like that, because of that very reason. But when it's in hot energy and you use the amperage field in there in the wrong way, it doesn't do anything at all. It completely cancels it out. You have way too much amperage in your system for it to work properly. So he uses that in his system as well, and he's got it in cold. He keeps that the magnets away from the coils far enough where he doesn't have a huge resistance in it, so he doesn't pick up a lot of amperage in it. Dissipates heat very fast, like Bedini did. Let's see. I'm wrestling with the idea of interesting bifilar loop of wire inside of my rodent coil. I was thinking the same thing in building a rodent coil that way. The thing is, I don't know that you have to have any field to it. And I would much rather use a ferrite core and use magnets in it. And I'm not sure the exact outcome. You have to build it in pieces and find out. But something like that may be better inside that rodent coil just because of the way it works. It's going to pick up energy if you wrap it. Bifilar coil, I guess if you build it let's see. If you build it on top and one on bottom on the piece of plastic, in the middle is going to be your dielectric. But I don't know how you take advantage of that in that coil unless you have something in the middle plastic, because that's what that thing does. It's a capacitor in the center. You pull out the energy. I'm not so sure you could do that unless you put a pickup inside the center in between them. Then it'd be different. Yeah, you'd have to show me because it doesn't quite make as much sense as I'd like it to. See, yeah, I think playing with some of this stuff is going to matter because you want an amperage field out of it. You want the magnets in there because you create a cold amperage field. That's the whole reason for it. Tim, we were talking earlier about the Meg and how it worked. And the magnets in there are a game changer because, as Bearden says, it's the free magnetic field that puts in there. And you're just basically putting in the frequency of it, and you're matching the frequency with the core itself. So as you match that thing, it creates a natural resonance in it. And then it's about shifting it back and forth, side to side in resonance. And that's basically all your switching does, is it pulls it back and forth, and you're getting the magnetic part for free. That was the interesting part about it. Now, in a rodent coil, could we do that? Very, very interesting concept. I'll have to see how it would set it up because of the wires and the coils, the way they flow. I don't know that it would mesh that way. I guess it all depends on what size you put in there and how close it is and what the frequency is and then the coupling of it. Definitely an interesting idea, though. Sorry, I got off topic. I knew we were talking about bifilar coils. So, very interesting. And John, by the way, I still we'll have John on again. And we were talking the last time off air about the Tesla Tower and a recreation of it. And I'd love to see, exactly what he's got in mind for that. Because, yeah, he said rodent might not work. I was thinking the same thing. The wiring is wrong for it. So, let me think. We were talking about the Tesla Tower. So the two bifilers is the capacitor in it to change the energy in there, but you have to get an antenna high enough in order to get the field up there. And then the one going to the ground is easy. You pound the copper stake into the ground. We can pull that field. That's not a problem. And then the coil in between it, we wrap it around wood. That's not a problem. And then the capacitance between the two, we could definitely make that work. I'll definitely have to see what you got going on there, John, because the more I think about it, the more I'm interested in it. And it has to do because my neighbor next door has one of those giant poles up there for the lighting for the neighborhood. So it's like super high, right? And if I can get an antenna on top of that, which the fat guy climbing a pole, it could be absolutely hilarious video. Maybe I can find some youngster to do it. But if I can get that, then I can set up that experiment fairly easy and then pull the energy out just like Tesla was doing. So, yeah. Yeah, keep changing back to your old chat picture. That's right. Well, because systems only work in certain ways, man. That's the way. That's what happened. You understand the fields that are going on. You understand how things work. You go back and forth on it. It's all about manipulation once you're done. If you can understand the principle, you understand the manipulation of something. That's the interesting part of all this, isn't it? Like that's all it's going to take. If you can understand the concept, you're going to be able to get to the next level on it. One of the things that I do want to create is that bit. Got me going, man, because I have a jewel thief circuit, okay, and it works on the same concept. Now, I don't know if it's exactly the same. So it wraps it, 22 times on the one end. On the other end, it's 11 and 11, and it pulls in the energy and gives me double out because of the way the coil is wrapped on the ferrite itself. Now, that's in my jewel thief circuit that I use. So I didn't take advantage of the cold energy or anything, but I took advantage of the way the Joule 3 saturates the core and keeping the frequency exactly the same. And you know when it hits that point. I put it on my oscilloscope and you can watch it. As soon as you push the button on this thing, what happens is it doubles. It doubles every time, man. Just like that. We could double the out because of the split in it. It's getting the same frequency one to the next, like two Tesla coils. What people don't realize is you don't have to keep it the same. So, yeah, gee, I can't wait to talk to you about that because I think I'm close to it, real close to it in the system. And I think, man, we're going to really take that thing to the next level because that's a system, you see, I can use on the rodent coil because it's the exact number of windings for each one of the windings on there. And then that way I can pull it out, but I can also solder two windings together and double it to one. I can make it, you know what I mean, half and half on there with one full, and then we can really pull out some energy on it. So on that one, when I run cold energy on my rodent coil from my Tesla coil and I keep everything really low, mostly resonance going in, that's when the temperature starts to change. We start to manipulate the environment on it because I'm taking the dielectric and pulling it into the center. That's the manipulation of that one. That one's pretty cool, and it'll run. You can pull the wire out of that Tesla coil, man, because it's not connected to anything. It's just down the center of it. It'll continue to run anywhere from 30 seconds. You know, I got it to 40 seconds, almost a minute. It'll continue to run because it's self-resonating. There's no heat to ruin it. It continues back and forth in self-resonation until it finally dies because there's no heat. That's one of the things. Heat kills everything. Runaway motor. I haven't gotten one of those yet, but I'd love to. That's awesome, man. Keep getting it going, bouncing back and forth. Yeah. With the bit you used? Nice. That's the way to go, man, because there you go. Perfect. It's basically about just resonance, back and forth, back and forth, back and forth. Keep it in resonance, man. That's why they tell you when you start creating too many Tesla coils that are exactly the same frequency and putting it around the one, you may get a runaway. It's the exact same concept when you put a transformer and a motor together and they're in the same frequency, you can potentially create a runaway. And if you do, good luck, man, because you're getting voltage out of there for days. Yeah. Nice. You received a Malcolm Bendel noted 1 to 20 redacted the other day. Looking forward to checking it out. Interesting. Thunderstorm generator. Love that device, man. You got the sphere inside of a sphere inside of a sphere. You're resonating it. You're compressing it. You're taking the energy. You're using a fluorescent light bulb in order to put the energy in there and start the process of breaking things apart. As soon as they get in that resonance chamber, man, boom, it starts to break everything apart. The molecules come apart. They capture the carbon, put them back together, and send it out. Total different material on the outside versus the inside going in. And the light bulb was to ionize the actual energy. They did the same thing in the water car, by the way. He did it inside the cylinder. He ionized it going in, put the water in there, and in the cylinder itself, it's a chamber that broke it with a compression. See, that's where all the energy is. As soon as they split apart, that's where the energy process happens, right there. As soon as they split, the energy process is right there. So in a compressed area, that energy puts out a volume. And as soon as that volume hits, man, it blasts it out. BMW actually just came out with water injection into one of their vehicles to get, I think it was an extra 20 horsepower, and they inject the water into it. Some people think it's for cooling, but cooling in a chamber like that, that's sheer ignorance in the way that goes. You do not want water in there like that to do that feature in there. That's the wrong way to go in a compression chamber because then you just have bent rods. If you don't split it into a gaseous form by the way that they put it in there, you're going to get bent rods all day long. So, yeah, there's a certain process to work that. And if you can't split it between the, hydrogen and oxygen, it's going to be a problem. So it splits in the chamber. They wouldn't put water in there because it bends rods. Trust me. If you ever had a boat, you'd understand that in depth because, yeah, a few bent rods in those suckers. Nice. Well, if you get that, man, just put it on the channel and check it out, man. Love to see it. Oh, let's see. Old airplanes use that. Nice. They already knew it. Already knew it, man. All these simple systems. You look at Hutchinson, you look at the water car, they're pretty much doing the same thing. You don't equate them to the same thing because one's in open air, one's in water. But the principle didn't change. Ionize. They're using compression. They're changing the energy itself, right? It's all the same thing, the breaking apart thing. They're simply splitting the molecule from what it is to what its base form is, and then recombining it. That's what they're doing. And it's all about saturation in Bedini system. Excuse me, not Bedini. In Hutchinson system, it's about saturation, which we cover all the time on here. And then we get over to the water car, it's about the energy that's coming from the split itself. So, yeah, a little bit of a difference, man, but it's really cool. Did he shave to get younger? I look a little younger, huh? Thank you for the compliment, I think. No, you get a beard, man, it irritates you after a while, and you got to take it down. I was getting just, especially after all the hot wings and stuff. Dude, it was burning all up in here and stuff, and I was just like, dude, I'm just gonna take it down. So, wife was all happy. Oh, look, you got some of the hair off your face, right? Nah, I don't care if I look younger or older. It doesn't really matter to me, man. I'm at the age of been married a long, long time, brother. I ain't out there to look any different for anybody, and I don't go to work anymore. I'm retired. This is what I do now. I just hang out in here and do this kind of stuff and hang out with you guys. So I don't have to go in there and shave every day. I hated doing that. Oh man, 2.0. I tell you what, it hadn't changed the color. Look, it's all gray still. All gray here, gray here. All of them. I earned them. I got 5 kids, man. I earned every one of these gray hairs. I got 2 grandkids, man. Trust me, I earned these gray hairs. Gotta show them off proudly. Yeah. Great young men. Funny. Nice. Nice. Good job, John. Yeah, sometimes, man, it always just work out. Testicle coil energy can be extracted with a capacitor at the conversion tube to change the tester power well. You can put it in the capacitor. I have done it. You're not going to get a great conversion out of the one wire, though. I'll tell you that right now. Because it's not set up to convert that way. You have no secondary coil for saturation. The key to over unity in those type of systems is the saturation of the second coil. That's the key. You see, it's simply converting 1 to 1 doesn't work because the energy is lost in heat in the system in any way that you get it. Saturation helps with reducing that because the colder you get it, the energy that goes into the saturating coil then is able to pull out in multiple ways. You can keep pulling wire after wire after wire off it until it starts to decrease the saturation level. So it works better. Anyway, yeah, it's a little bit of a different understanding. You really got to take that PMP circuit down like really far in order to get to that level where it's not creating the heat in there. So I usually do like a lot of the water experiments I do with the PMP when I want to do the conversion over to my rodent coil or something. I'll pull out the ZVS because I don't want perfect resonance in there. I want a saturation, but I don't want perfect resonance. That's kind of one of the keys to that. So I did do a lot of water experiments with a wall wire. So like a 14 gauge wall wire, solid copper with the insulation around it. Those were great. So you're able to put it down the center, just make sure it's all the way in the center, doesn't go side to side because it'll fry your coil. All the way down the center. And then you're able to put that in water and you're able to convert that. That works a lot better because the compression fights hard to get to the insulation, to get to the copper in the center. So a little bit different, yeah. And the thicker the copper, the more resistance it has. Therefore, the energy takes longer to get through it. So it'll actually be cooler when it comes out of it. Kind of a trick. Sometimes, man, I run that circuit on that Tesla coil, man, and it'll get you. It gets me a lot. It gets me through the orange. I mean, this just cracks me up. I put it into an orange, man, and it's zapping my finger through the orange. It just doesn't care. It has a mind of its own, I'll tell you that. Yeah, when I did that pond, I did a 12-foot by 12-foot pond in the backyard. Dude, I was using that Slayer exciter circuit with the Tesla coil, like the one right here next to me. And I put it in that pond. You put it in the center and it starts to light it up. You can actually, this is what's the cool part, put a wire into there to a primary of another Tesla coil and get it started. I also put it directly into a secondary of a coil and it gets it started. Through all that water. And pond wasn't very thick. I mean, we're talking about this. The key was the sand in it. I had put the sand in there and it's going into the quartz in the sand and it's creating more of a resonance in the sand, which actually pushed through and helped the energy push through everything. That's why when Tesla put this thing into groundwater, man, he got it to light up. Now, around the pond was cool too, because then you take your 4-foot light like a cane and you're walking around the outside of the pond. Why is that working? Because the water itself got under that layer of the outside of the pond, and then you have this layer in between. So it's like a null zone, but then of dirt, and it goes through. Once you put the light on it, it completes the circuit, though. That's the crazy thing. It's a non-conductor that feels like a semiconductor because of the minerals in the dirt itself. Totally interesting concept. Worked perfect. I did it in several videos actually. And I did it with my orange just today. I was over there putting the thing to it because I knew that I tended to do a radiant field and I got it to push out. And when you split it, it splits like a capacitor. You can pull it apart like just like two bifilar coils, man. You can put that light bulb right in the center. It's like a lightsaber as soon as it turns on. And then on the outside, it's pulling out a field that's radiant, man. It goes out everywhere. I love the fact, by the way, when I did the orange, I set it on a pedestal and you get 360 degrees now of energy. So if I took that same orange and kept the same concept going, now I compress it. I put mineral oil around it. Just take a baggie full of mineral oil and put it around it and make sure that it doesn't touch the sides. I'm going to compress that field even further. Now we're talking the energy that pops out in certain areas. Watch yourself because that's going to be a high level. It goes down to um, Edwin Gray's tube. His tube that he built, he uses the exact same energy in there. He has a cold current tube going to the center of it. He has each layer going. He triggers it with some kind of a high voltage field that goes in there. I've done the conversion and it worked. You're able to pull an amperage field out of it in that cold current tube once you do it. It's a neat thing going on there, man. We were talking earlier about the tar. And, Darren and I had the same idea. That tar would probably hold it in just like that mineral oil does. So totally awesome concept, man. So yeah, love to do that. So All right, guys, it's been about 3 hours. I think it's about time to call it. So, guys, awesome stuff. We got a lot of things going on, man, doing a lot of things. I'm changing my process out here. Hopefully you guys enjoy it. I think it's going to be a lot easier for everybody. You see me out there, you see me describing things, we'll put it on the whiteboard. And we'll just do all of it that way. And I think that's the style of video I need to do from here on out. So anyway, with that said, I want to thank everybody for watching today. Also, real quick, I'm going to put this in the chat there. If anybody wants to help out, man, this right here is Joe Going Mining. Thank you, Tim. I appreciate it, man. If you want to help Joe Go Mining, which we all want to see Joe get out there and dig in the dirt and pull some crystals out again, man. Totally awesome time last time he did it. Yeah, throw him a little cash on his fundraiser, get him out there. So, with that said, man, thank you guys very much. Have yourself a great night.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.